this is a call to action to join the movement. Let's just see, where are we going? Okay. There we go, okay. So what have we accomplished? Last year we showed you a collection of chatbots. These are highly configurable chatbots. We showed you Lumi, we showed you Bruce, we showed you Penny. Lumi is an FAQ chatbot loaded with a knowledge base of the facts about Quai, the weekly public meeting transcripts and so on. And it's a vanilla RAG chatbot. It can listen, it can talk. Then Bruce Schneier, who's one of the speakers coming up right next, he said, hey, can you make me a chatbot? But I don't want it to have a face. He says, chatbots are services at best. They're not friends. So we loaded up with a knowledge base of his 14 textbooks. And it's fantastic. You can have a conversation with a knowledge base. That is empowering. And then Penny is a virtual teacher's assistant. Okay, and that is a knowledge base that shows off what we're doing. So how have we moved since then? Personal AI has advanced within Quai. We set about in two different directions. In fact, we had two competing teams. One team, the PyOS team, went along the path of generating a multi-tenant, highly configurable RAG chatbot with an entitlement framework and earned beta applications from 30 academic institutes. The institutes have applied to join the beta. We haven't released the beta yet. And then, completely out of left field, comes the QuaiNet research team that said, no, we don't want our chatbots to be server-based, even if it's multi-tenant. We think that the future of AI is distributed, and it's at the edge. And so you'll be hearing from that. Later on, you'll be seeing a demo of exactly that. And you'll be getting a call to action to contribute to this new vision of AI running distributed on a peer-to-peer fabric. Okay, so Quai's research group, you'll hear from, is about making AI smarter. You'll hear about GraphRAG in life sciences, about making AI faster. You'll hear about the subquadratic neural network research and the state space modeling, and also making AI greener. AI's got a disastrous carbon footprint. Moving it to the edge will definitely make it greener. And so this is the team that we presented, my good friend over here, Matt Small. Thank you very much. He's the founder alum of Quai. Afshin Beheshti is not with me here on stage, but he sends his regards. And now the team is, we've hired a new board. So we elected a board. Larry Namer, the founder of E-Entertainment, you might see him on the booth in the next few days. Ruth Rasool in the audience. Ted Cohen is on the board. He's a music exec. Rika Nakazawa is an exec within NTT. Sam Johnson couldn't be here today. He's dialing in from Vancouver. And Yunus Atif is on the board as well, former CTO of Arcus Nexus. And then we elected some officers. I'm just going to highlight some of them. Zachary Schenkler, I'm not sure if he's in the audience, say hi, is a VP of Quai. Myra is right here. She's Quai board secretary. Our very own Doc Searles, Chief Intention Officer, will be dialing into this call. And then Christian Randieri is our EMEA director. We opened up an EMEA chapter. Okay, so that's it. Look, call to action. Join Quai and hit up the QR code. Let's get the membership over 1,000, and you can do it. Thanks.
Thank you, Riza. Thank you, Riza. Appreciate that. Next up is our first keynote. I'd like to invite Nolan Bushnell and Ruth Rasool up here. We've got some chairs situated over on this side here. This will be a panel, a fireside chat. It's my privilege to introduce Nolan Bushnell. He's a pioneering engineer and entrepreneur who co-founded Atari in 1972 and launched the iconic arcade game Pong. 5 years later, he established Chuck E. Cheese's Pizza, and taking over many of our childhoods by merging casual dining with some good old-time arcade games. Over his career, he's founded more than 20 companies, including Catalyst Technologies, one of his earliest business incubators, and BrainRush, an innovative educational software firm. He's inducted in the Video Game Hall of Fame and a Consumer Electronics Association Hall of Fame. Bushnell continues to shape interactive experiences worldwide, guided by his principle that great games should be easy to learn and difficult to master. Now he turns his sights on education and how AI can augment our learning. It's also a pleasure to introduce Ruth Rasul, proud LA resident and College of the Canyons and UCLA alumni. She has a deep academic research background in British, American, and comparative literature, an early adopter of emerging educational technologies. She partnered with Kwai's Beta Project to integrate Penny, the Gen AI-powered virtual teaching assistant that delivers 24/7 course support for her students. Beyond her work at College of the Canyons, Ruth savors her time at home in Santa Clarita or traveling, particularly back to England, befitting her role as an English teacher. Please join me in welcoming Ruth and Nolan for an insightful fireside chat about AI in education, amplified intelligence through games. I think you might need to turn that on, Ruth.
Better? No? Yeah. Nolan, hello.
Hi there. Good fun to be here.
Yeah, we didn't get a chance to chat very much ahead of time, and I've got lots of questions for you. But I feel like you've been part of my life because there was, many years ago, the then boyish Riza Rasul.
Was I drunk?
No, you weren't there as such, but when the pubs kicked out, we would go back to his house and I would watch him play on his Atari game console. And then when we arrived in Los Angeles in 1994, the company that Riza was working for took our family to Chuck E. Cheese. That was our first introduction to Los Angeles. And then there have been many birthday parties there ever since. But now I'm more interested in what you're doing with AI in education as an educator. And I've got lots of questions, but I think I've kind of filtered them down a little bit. And this will just be, we'll see where we go. So you advocate for making learning game-like. How do you think AI tutors can complement your vision?
Well, first of all, I'm reminded of the story about Johnny went to school. Teacher said, "What's the difference between ignorance and apathy?" He said, "I don't know and I don't care." An old friend of mine said, "You never want to do anything but start a speech with a joke." Anyway. I think it is, isn't it?
Yeah.
Okay. Sorry about that. I'll try to keep it right to my lips. The reality is that we remember 5% of what we hear, 10% of what we see, and 80% of what we do. So the sage on a stage metric is wrong. And so gamification of education forces a child, the adult, the learner, to remember, because you are engaged. You're part of the activity. We created some software that literally you responded to it every 3 to 5 seconds. And we found that we could create and learn at a rate that I felt that we could do a complete high school 4 years of high school in less than 3 months. That's good. AI. What AI allows us to do is adaptive. And, you know, I kind of like to set up metrics of how do we know when we've won? And I believe that we have a world in which there are no grades and no grades. You say, well, what do you mean? 3rd grade, 4th grade, 5th grade, that implies batch processing. And there's so much variability between the way kids learn, the way adults learn, the level of maturity within that age group. A year for a 3rd grader is, you know, from the beginning to the end is really a lot. So batch processing was invented when it was the sage on the stage. Teachers, lecturers, professors, not necessary anymore. We can adapt, and with AI, now the AI can start to ask some questions. How does this person learn? What's resonant? What's effective? Secondarily, it can know when the student is getting bored and maybe needs a break. Typical high school student's attention span is less than 20 minutes. Why are we having classes for an hour or 45 minutes? Wrong. Just a waste of time. That's why disruption can be a problem, because you just get bored. And so, you know, why do you disrupt when you're a 14-year-old boy? Because you're a 14-year-old boy. And anyway, second, no grades, A, B, C, D. What does that imply? It implies competition with other kids. What does that have to do with education? The only thing you should be doing is getting better than you were yesterday. And so if we can get rid of grades, we will have a system that is more effective, safer, egalitarian, and promising.
I did try assigning grades, talking about A's, B's, and C's. I assigned J's and M's and P's just as an experiment, and people would try and derive meaning from it. It's as meaningless as the A's and B's and C's, so it doesn't work. What misconceptions do you think exist about AI's role in education?
You know, I really haven't heard many people who've dealt with that. I do know this in my tests so far, that kids prefer AI to a college kid who's doing things. Kids universally hate tutoring because they're generally an hour. As I said before, the attention span is less than 20 minutes. And with AI, it's a fingertip away. And so when they want some help, they can get it equivalently. AI right now is not as good at tutoring math as I'd like it to be. And that's one of the things I'm trying to. Language arts, English, foreign languages, history, wonderful. Math, a little bit deficient. I'd say I like to quantify things. I think that we're about 60% of the way there with math and 90% of the way there for most of the other language-based stuff. One of the, I shouldn't go here.
Oh, go on. Go on.
One of the things that is a promise and a curse is AI, computer intelligence, in the next 10 years is going to be the knowledge equivalent of the atom bomb. We as a species are very good at adaptive. We're just not very fast at it. And that scares me. So for example, how many people in the United States will be unemployed because of self-driving cars, full self-driving? The typical figure is 15. I think it's going to be more like 25 million people. You know? So not only are we going to get rid of drivers, we're going to get rid of insurance adjusters. We're going to get rid of body shop people. We're going to massively get rid of the number of cars that are manufactured. And then that whole chain of cars manufactured, cars, you know, sold, what have you. And the reason for that is that if you have self-driving robotaxis, you will be able to get an Uber for under 30 cents a mile, because electric cars, nickel a mile for electricity, capital cost of the vehicle, maybe 10 cents a mile, maybe 8. No driver, so then how much profit do you need? 30 cents a mile? That's cheaper than the New York subway. You know, so that's one part. Second part, AI will eliminate 80% of the teachers. Not necessary anymore. It will totally decimate colleges and universities, which is way overpriced and not very effective. The things that a lot of kids are learning will never pencil out in their job skills. And I always believe that we're trending towards a perfect knowledge. Kids are going to learn that, parents are going to learn that, and all of a sudden the whole ecosystem shifts. So that's my dire prediction.
Thank you for that. I'm out of a job now. And I think that is one of the, maybe it's not a misconception, but it is a fear, and that's a barrier for AI in education, because the educators are seeing their jobs perhaps disappear or be adapted. They're still...
Well, you know, here's the problem. Everybody has to be a continual learner. We always have, you know, I look back at my young adulthood as being young and dumb, you know, and I did some pretty interesting things, because the only thing that I had going for me is that most of the other people were younger and dumber. And it was and now that I'm old and dumb, because, you know, I'm in that phase of life where I'm just short of mewling and puking, as the bard would say. Anyway, what we really want to do is constantly predict the future and adapt.
I think you've answered what was my last question about what has surprised you from your predictions some years ago. What has turned out to be true, what has turned out to not be true. And then maybe I can combine that, because you kind of answered that already. What do you think should remain human-centered, and what do you think AI can take over? Give me some hope for keeping my job.
Well, one of the things that happens in life is as costs go away and gatekeepers go away, you have a blossoming of creativity. And so I actually believe that creativity is going to explode in the next little while. And what that means is it's totally unpredictable. You know, that's the nature of creativity, is creating something that hasn't previously done. And so all I can say is that I think that we're going to have an explosion of creativity, which means that we're all going to be shocked, particularly by the good ones. And there's going to be some really bad crap done too.
And you'll still be quoting the Bard, so that's something.
Yeah.
Matt has been waving a sign at us. I think we're out of time.
As we should be, because it is. But I want to tell you that that the past, present, and future walked into a bar. It was tense.
Fantastic. Thank you so much, Nolan. Thank you so much, Ruth. Really appreciate it. Our next keynote speaker is Bruce Schneier. And by the way, thank you for letting us sort out some of our AV issues as we're going through. What good would a presentation without live AV troubleshooting be? So appreciate that. Our next speaker is Bruce Schneier. And that should be a name many of you in the audience already recognize. Bruce Schneier is an internationally recognized security technologist, famously dubbed a security guru by The Economist. He is a New York Times bestselling author of 14 books, most recently A Hacker's Mind, and his widely followed newsletter, Schneier on Security and Cryptogram, have reached over 250,000 readers. A fellow at Harvard's Berkman Klein Center and a lecturer in public policy at Harvard Kennedy School, Bruce also serves on the boards of the Electronic Frontier Foundation and Access Now. Currently, he's the Chief of Security Architecture at Inrupt. Please join me in welcoming Bruce Schneier, who's joining us live, albeit virtually, for his talk about trust in AI. And I'll get you up on the screen here in just a sec, Bruce. Give me 1 sec to get Bruce going here. One moment here, Bruce. Almost there. Almost got you. It's like I've never used Zoom before. Here we go. Okay, Bruce, we've got you here, and I'll turn this around so you can see your audience as well. And we don't have audio here. Give us a check 1 2, Bruce.
Check 1 2, Bruce.
All right, thank you. All right, here we go.
Okay, I can't see you. I assume you're there. And I'm glad you're there. I think this is really important work that is being done here. I want to talk about AI and trust because I think it matters for what's happening here at Quai AI. And I think it matters a lot for AI. Trust is actually a really complicated concept. That single word is overloaded with a lot of different meanings. So there's a personal and intimate trust. When I say that I trust a friend, it's really not about their actions and more about them as a person, right? I know them, I know their intentions, and I know their intentions will inform their actions. I want to call that interpersonal trust. There's also a less intimate, less personal trust, right? I might not know someone personally or know their motivations, but I can still trust their behavior. I mean, I don't know if this person wants to steal, but I can maybe still trust that they won't steal. That's really more about reliability and predictability, but we still call it trust. And I want to call it social trust.
Disconnect from the audio.
Talk. The ability to trust strangers. I hope that's not me echoing through the room. So interpersonal trust and social trust, they're both essential to society today. Right? We have mechanisms that induce people to be trustworthy, that allows others to be trusting, and that enables trust in society. Right? That's sort of the frame. It's not perfect, of course. There are always untrustworthy people, but it's good enough for society to work. trust. About four systems: our morals, concern, cause corporations slow AI. And if you think about it, they're profit maximizing machines. That whole paperclip maximizer is basically a startup business plan, right? The most successful ones do whatever they can to achieve their goal. David Runciman at Cambridge in the UK, he has a book called The Handover. And he writes about governments, corporations, and AIs all as these superhuman machines that are more powerful than their individual components. Another science fiction writer writes a really, I think, a perceptive point that our fears of AI are basically all of this. So this is the story of the internet. Surveillance and manipulation are their business models. Enshittification is how things work. And we use lots of services like there are agents working on our behalf when they are in fact double agents working for their corporate owners. We trust them, but not trustworthy. So I think AI is down the same trajectory, but it's going to be worse for several reasons. The first is that these AI systems will be more relational. We're going to converse with them using natural language. And as such, we're going to naturally ascribe human-like relationships with them. And we see that when people form personal relationships with AI chatbots. And that relational nature is going to make it easier for double agents to do their work. So did your chatbot recommend a particular airline or hotel because it was your best deal, or because they got a kickback off the back end for some provider? Like when you asked them to explain a political issue, did it do that fairly? Or was it biased towards the political party the company liked or gave them most money? At least Google ads show you that it's an ad. It's going to be much harder with AI. Second reason I worry is power. Right? So sometimes we have no choice but to trust someone or something because they are powerful. Right? We are forced to trust the police. They're the only law enforcement in town. We are forced to trust some corporations because there are no viable alternatives. Or maybe more precise, we are forced to entrust ourselves to them. And we're going to be in the same position with a lot of AI.
Recording in progress.
Of these platforms, one of the promises we talk about here, you lost my audio. Is that true? Wow, when did you lose me? Ten seconds ago. Okay, so we'll just move forward. The third reason to be concerned about the AI is that they'll be more intimate. So one of the promises of AI, I mean, even AI here, are the personal digital assistants, acting as our advocate with others or as our butler. And that's going to require intimacy greater than our search engine, email provider, cloud storage system, phone, right? Trained on everything we do. Because we're going to want it to help us in all sorts of ways. Notice our moods, anticipate our needs, be our therapist, life coach, relationship counselor. This is tailor-made for us to think of it as our friend, right? Conversing in a natural language, we respond in kind. If it's a robot, it looks humanoid. It will interact with the whole of our existence. And we're going to want to trust it. It'll use our mannerisms, our cultural references, a convincing voice, a confident tone, authoritative manner. Its personality optimized to exactly what we will trust. And that scares me. And we need
Recording in progress.
And we're going to need both. Right? We're going to need these things, eh? Yes. What?
That's their IP. That's their IP.
All right. All right. So basically trustworthy AI, right? From the top of the stack to the bottom. Behavior, limitations, training, biases, goals, and that is secure against hacking. And to make that trustworthy AI, it's social trust. And I said in the beginning, that's through laws and technologies. Right? It's about predictability, reliability. And the failures come from one of two places. The powerful corporation controlling the AI or others manipulating, hacking the AI. At the end of the day, AI is a computer program is also true for AIs with the added addition of things like prompt injection. And they're all going to be used in some adversarial environment. Someone will care about the output and will want to manipulate it. And when I think of hacks, I think of sort of three different levels, right? First, you're going to want to manipulate the AI's output. If you can't do that, you want to eavesdrop on it. If you can't do that, you might want to disrupt it. Think of an AI being used in a trade negotiation in another country, or as a legal researcher, or as, something in the judicial system. Doesn't matter how accurate or powerful or hallucination-free the AI is, you can't guarantee it hasn't been hacked. So I think there's a huge need for AI security. I think it's a very hard technical problem. I think it is a problem not really of confidentiality, but of integrity. Right? Data integrity from point of collection through use. Okay? Remember when you used to put stickers on street signs to fool the car AIs? The data integrity issue. Manipulating training data, data integrity issue. Prompt injection, data integrity issue. If we're going to use these AIs in a corporate environment, like imagine a corporate AI into kind of thing Microsoft wants with Copilot, right? Generates reports, analyzes decisions, does corporate stuff. Integrity is vital for that. I think this is a hard problem. I think it's a problem that needs a lot of research in the security community, and one that is going to be essential to making AI work in any of these kind of a systems matter. Local AI matters here. I mean, today most AI happens in the cloud. My guess is that's going to change, and AI will move on to home laptops and phones, and people are going to run their own models, maybe even train their own models. Different problem, but also but similar in this need for integrity. But, even with all the tech, I don't think the market provides this on its own. Right? Corporations are profit maximizers. They're not going to build systems to your interest, they build them to their interest. And here, I really want government to step in and enforce trustworthy AI systems. You lose me again?
Like a lot of audio visuals.
I'm good. All right. So,
No,
right,
he's
well,
talking about integrity.
I'm going to try to bring this in for a landing. So I want to see governments with policies to incent trustworthy AI. laws about transparency, AI safety, minimal security standards. Models. And also, and why I'm here, is we need public AI models. We need AI models that are not built by corporations, that are not built under the corporate profit model. Not to replace them, but to be as a counterpoint. And I mean something very specific here. I don't mean corporate models the public can use. I don't mean corporate models the public is licensed. I don't even mean an open source model the public can examine. Right? I want a model built by the public for the public with social accountability, not just market accountability, available for anyone to build on top of, so universal access, and a foundation for like a free market in AI innovations. I don't think we ever make AI into our friends, but we make them into trustworthy services, right? But only if government mandates it. And it is within government's power to do this. Because I think the point of government is to create social trust. And while this is going to be hard, I don't think it's any harder than the other things government does. We need government to facilitate trust in AI. So I have 3 work streams. I'll close with this. One is AI security, as you know traditionally. 2, AI integrity, defined very broadly, and regulations to align incentives. We need them all, and we need them all soon. And to me, that's how we will create social trust in AI. And with that, I am done. Apologize for the glitches. And I'm going to try to be there in person next year. This is silly.
Hey, thank you so much, Bruce. Big round of applause for you here. We hope to see you next year, live and in person. And no, our apologies for the technical issues. A bit of a dongle gate up here. If anyone has an RJ45 to USB-C in the bag, that would be super helpful. So thank you, Bruce. Appreciate it. We're gonna roll right along, and our next speaker for keynote is Faye Ajramondi. It's oh, look at this. Hero. A round of applause. Thank you. You're gonna save our next couple virtual speakers. We've got 2 more. I'm gonna get that done right now. All right, I'll finish this intro here for you, Faye.
Recording in progress.
Thank you, Bruce. Thank you so much, Bruce. Okay. to put this one back up with you here. We got one down here for you, Faye. Check. There we go. It's my pleasure to introduce Faye Ashermandi. Faye is the founder, CEO, and board member of Mimic. Mimic, M-I-M-I-K, is a trailblazing hybrid cloud edge technology, and they're gracious sponsor of the Quai Summit and Hackathon. Check out mimic.com. Formerly, Faye is the CEO of Not Mobile and Vodafone Zone. Hope I pronounced that way. All right, cool. And she's co-founded 3 technology startups, including Mobidia and now Mimic. She holds numerous patents in telecommunications, edge computing, and mobile networks. She's recognized as a top 20 Canadian tech titan in 2022 and an Edge Woman of the Year in 2020. That was before Edge was cool. Faye also serves as a Forbes Technology Council member, advises organizations on digital transformation. With a degree in electrical engineering from Concordia, her international work spans North America, Europe, and the Middle East. It's driven by a commitment for digital equity and decentralized cloud innovation. Please join me in welcoming Faye Ashermandi and her talk, The Fifth Element, Operationalizing the Agentic Economy.
Thank you, Matt. Thank you. Thank you, everyone. It's a great pleasure to be here. Apologies if
Other direction also, just kind of tip it back. There you go.
my God, I feel like I'm singing a karaoke. How about that? All right. Apologies if I've seen you, didn't say hello properly. It's been one of those days. And remember, I constantly have to carry 2 glasses. So I may have not seen you properly. Anyway, so Mimic is a company that is formed by the first generation mobile internet people. We have some of the world-renowned experts in wireless communication, cloud, API, software system. So we practically come from the software system background. We have seen what worked, what didn't. And we kind of saw this AI revolution coming our way. And that's what and how we created what we created for this agentic native. To talk about agentic native, I don't have any slides. Actually, I dynamically adopted and put some notes together. To talk about agentics, I have to stand here. There is no presentation. these are my notes, right? Okay. So let's look at a healthy society. A healthy society operates efficiently when individuals contribute to society and economy with their expertise, and they participate based on the context. At any time, I may participate in this economy with certain skill set that I have. Although I'm a person, but at some point I may be marketing, somewhere I may be technology, somewhere I may be just a person that having fun and singing karaoke. So different contexts is define our contribution to the society with different skill sets. And we do that without compromising our privacy, without practically enabling big brothers to watch every step that we make, which is not the case in the digital world today, and without losing autonomy and control. But we operate within certain framework of agreement. We heard today Matt mentioned that we're operating with a SCaLE code of conduct. And that's the code of conduct that we're operating today. But tomorrow we may be in a different code of conduct. So in such society, dynamic adoption is the key. As I said, today has been one of those days that all orchestration failed for me. Basically, you come with a certain agenda, you come with a certain expectation, but everything one after another failed. And what do? You adapt dynamically. Dynamic adoption is part of the way that human society works and operates. And that's how the system needs to operate in that context. It's a natural way that society operates. A society learns, adapts to new regulations, adhere with new policies, and practically share knowledge accordingly based on an event, policies, and contribute in a continuous way to society. Now let's look at agentic and AI agentics, right? Just like new citizens entering a new workforce, we are seeing AI agents and physical AI are entering the new workforce. They are practically the new citizens of our workforce, of our society, digital ones, and they are going to contribute to this digital economy. And we have a choice that either we're just gonna let one company own it all, or we each gonna have our own agents participating in this new digital economy. We have to understand that agents are not static entities. Human may look as perceived as monolith, but at every part of our brain, at any time, we are participating And today we have about 5.4, 5.6 million mobile applications that are running across the different app stores. They are like babies. They're constantly relying on cloud. They constantly have to go to cloud and back. Every transaction on a mobile application practically goes to cloud where the workload is hosted and come back where the response comes in. We just saw what happened with Zoom and how many times Zoom got disconnected. Because mobile solutions and mobile technology was designed for one person, one phone, making a phone call. Today we can hardly make that phone call because every application on our device is equivalent to practically 100 mobile phone calls at any time. Because these mobile applications are constantly pinging the network, constantly taking bandwidth from base station, constantly need to go to cloud to workload where the workload operates and come back. 5G, 6G, 10G is not going to solve it. It's basically we're running against the law of physics, and we need to change that. So agents need to operate like adults. As adults at any time, I decide, I ping my API and I say, hey Faye, can you lift this? Yes, no. If you can, lift it. If not, call for help. Hey Matt, my badge, my registration is not in the system. They told me to go here and fill in the information, but this system doesn't work. Can you help me? So it's a cascading of first I call my API, then I call the API for help. If none of these things works, then I should call someone else and escalate above. That's how agents need to work. And within the context of the operation, agents need to dynamically adopt. They need to decide whether they can do the work themselves or call for help. Where is help? Is help in the same room? Is help in the same building? Is help in the same city? Or help sitting somewhere in Europe that I need to go and ask for help for? And that's what dynamic, agentic discovery and collaboration between agents with API first becomes such a big issue. You heard me talking a few times about context. Context is a frame of reference to reality. Today I embarrassed myself with someone saying hello to me. I knew the face, but I didn't know where I met the person. But I immediately thought about work. And this person said, I hosted you in my place. And I banged my head and I said, I'm so sorry, I was not even in the context of entertainment at that time. That's the context, the frame of reference to reality that says, hey, I hosted you for right? Today, context doesn't exist in mobile application because your data constantly goes to cloud and somebody is trying to make assumption of what that context is in order to make a decision, which have both the privacy issue and the fact that a lot of decisions made based on assumptions versus at that moment I say, who am I? Where am I? What is my relationship with you? What is it that we're talking about? And that context becomes very important for agentic and agentic economy. So, and just like human population, as we increase, agents are gonna increase. They're gonna get populated. According to McKinsey, by 2030, we're gonna have billions of agents operating. And it makes sense because if you just look at this room, how many collective expertise we have from the number of the people in this room, we may be what, 10, 20, 50, whatever. But from the collection expertise that we each carry is probably multiply the number of people. So every agent is going to be an expert in a specific task. And that's why these agents are going to populate and are going to be in billions of agents, where they each responsible for a process of task, and they will participate in this new digital economy. So think about it, if mobile internet was in the billions of magnitude, agentic is going to be in trillions of dollars of magnitude. Because billions and billions of agents are processing data, extracting knowledge, and exchanging knowledge. That's what we refer to as knowledge as a service, which is no longer SaaS. SaaS was about mobile internet, SaaS was about cloud, SaaS was about putting a service up there to serve your need. So a thriving human economy needs efficient infrastructure, right? Roads, cities, shopping districts, policies, framework. A system that is flexible, resilient, energy efficient, and can provide and operate and can enable us to operate independently and yet in collaboration with others. And this is where the knowledge as a service is. Now, today, on one side, we talk about AI. On another side, when we talk about infrastructure, we talk about old, outdated infrastructure. containers, orchestration, cloud infrastructure, and to my shock, recently I heard VPN to secure agents. I thought, imagine as advanced civilized AI society that when they communicate, they have to use fax machine. That's what VPN is really. It really is for the AI agent world. So that's what we mean by new infrastructure, new software-defined infrastructure. And that's the key. Sometimes when I listen to talks and when I listen to conversations, it reminds me, and I have a lot of gray hair, it reminds me of the time of mobile browsers, mobile application. Before mobile native application, the first generation of mobile app was about let's grab a browser, shrink it and put it on the phone. Very quickly people realized that that's not sufficient. Usability is not there, delays are too much and latencies are too much. And in fact, Facebook, now Meta, was the first company that decided they're gonna go mobile native. And they said, we're gonna start developing this monolith app that resides on the phone, and the workload to process this monolith app is residing on cloud. And that's how the new infrastructure and cloud native and SaaS got started. So this is what we are facing. We need new software infrastructure and new tools and new enablers. So instead of thinking centralized or decentralized, we have to think hybrid. And hybrid means flow of data, flow of workload starts from where the data source is. On device, this is where the data source is, this is where the context is, and this is where process of the workload can start. And based on the context, you can decide whether to send that traffic to another workload on the same device, to another workload on another device in the same network proximity and account, or to send it to cloud. And that's what agentic is all about. It's about having a runtime environment, not old containerization, having an AI runtime environment, having an API gateway, being able to dynamically discover resource, being able to dynamically discover agents, having zero trust security and being zero touch configuration, being able to work on any computing device over any network with any cloud without hassle, but create this dynamic choreography and the edge and utilize orchestration. orchestration in cloud. So as Matt said, human-centric, because solutions with a prompt you can basically invoke and trigger a series of systems that collaborate with each other in order to drive the outcome and solve the right problem. And microservice construct is the simple and nimble construct that when you encapsulate a task, a job into a microservice, you can practically create AI-enabled systems that expand and shrink together. This is the true and real butterfly effect. Because an event practically in the physical world, don't think of prompt sitting and typing something to the system. Think of prompt as when this door opens and triggers a sequence of events for agents to discover each other, collaborate with each other, and drive to outcome. And that's what Mimic has done. Mimic is, we have created the new software infrastructure. There is a cloud-native serverless operating environment that resides and downloadable on any computing device, provide an API gateway, provide this dynamic choreography, and decouple the business logic and workload from the underlying heterogeneous communication that creates and enables that knowledge as a service. And if any recommendation I have for any of you to start develop your agentic expert services that can be ready to enter the economy and the marketplace of the digital economy. Thank you very much.
Well done. Fantastic. That was fantastic. Thanks so much. Thanks, Faye. We are so grateful to have Faye as our hackathon sponsor, the innovation sponsor, and our hackathon, which was themed around emergency response, emergency preparedness, and recovery, is very relevant for this town. This very room, this conference center, was the emergency center. It was the evacuation center. Where you're sitting now, there were cot beds just a few weeks ago. So this is a town that's emerging from the fires of LA. And when you think about how technology and artificial intelligence could improve our resilience, could make us more robust and more capable of being prepared, being able to respond, and being able to recover. That was the question that we actually posed as a challenge to some developer, hacker, innovators, some of you in the audience here. And it Arjumandi's very technology from Mimic that is the most relevant in being able to create systems that are complex, that can run on ad hoc networks, can run at the edge, can run in the cloud, but when the network goes down, the system can still operate. I'm tap dancing here. I want to make sure that we've got everyone connected, and I see on the screen nearly, we just need to project that, and we will be up and running. Our very next speaker will be Doc Searles.
Thank you, Riza. Appreciate it. It's my pleasure to introduce Doc Searles. Doc, regretfully, was supposed to be able to be here today, but wasn't able to make it out due to some unforeseen circumstances. We are very happy to have him dialing in virtually. Doc is a journalist, an author, and a prominent figure in the open source movement. He's devoted 24 years to the Linux Journal, where he finished as editor-in-chief. He co-authored the Clue Train Manifesto, and wrote The Intention Economy When Customers Take Charge, both of which have significantly shaped the open source projects, including Quai, where Doc currently serves as Quai's Chief Intention Officer to ensure we stay true to our mission to empower users with control in an age of personal AI. His talk will focus on personal versus personalized AI. Please join me in saying what's up to Doc Searles. Doc, you're up.
Oh, shit. Wait a minute. Okay. I had myself up at 4:30, so I'm still working on my thing.
You're on, buddy.
Oh, shoot. Okay. Well, this will be very random. Hang on. Let me put my headphones on. Let me switch to that. So we're actually ahead of schedule. This is at 1:30 on the calendar. Hang on, let me go into PowerPoint. All right, go into Zoom. And switch to hearing this through headphones. Okay. Am I, okay.
We can hear you loud and clear in here, Doc.
Okay, good, and you're in my headphones, so that's good. All right, so, I'm going to bring up on my shared screen here. Share. There it is. And this, let's share it. All right, so my topic, and I'm going to do the full screen thing here, is personalized, which is corporate AI, and that's almost entirely what we get now, versus personal AI, which I maintain we don't have yet. We're working on it. I think that is Kauai, is way ahead of most others on doing this, but there's a danger in thinking that what we get from these people, these corporate entities, is what we're going to get in some other form from personal AI. And the important thing about these guys is what they've done is scrape the entire freaking world. And they are informed by the world. We need to look at these in terms of the data that underlie them and the data that they use. That data is gigantic, and it's wonderful. I'm glad they have it. I'm glad models have been based on it. We'll use some of those models. It's an amazing way to make sense of everything, so far as everything can be found. But it is not our lives. Our lives are, let's see if this is, well, okay, I'm going to jump ahead to, yeah, I don't have it. Okay, skip it. I'll go back to here. Yeah, I'll go to this one. Yeah, boy, I really wish I had a little more time. But anyway, if you look at our lives, we don't, like the data that comprise our lives. I'll skip out of this. I'm just going to go to, actually a better place. No, that's not going to work. All right, I'll go here to reshare. Okay, I'll stop sharing. Stop sharing. I know the meeting's being transcribed. Okay, share. Stop sharing. Start sharing. Share. Here. Okay, so if you guys will go, just write this down. My first name at my last name.com, doc.searles.com. Go to /personal AI. I've written a lot about this. If you look at what's here in personal AI, which I say is having a personal AI is like having a personal computer. It's yours. It's not AI as a service, which is what we're getting from all those other guys. And it's comprised, we need to be our personal AI needs to be fully informed by the data in our lives. This is a mess right now. It's in many different places. If we look at the things in this image, schedules, Business relationships, well, to some extent, those are in LinkedIn, but those are really kind of crude, not very well validated. They're public, they're not private. They're not really what we know about what we did at work anywhere. Our subscriptions, including all the screwage is tied up with subscriptions, our past work, our contacts, our health, our calendars, I mean, our health providers and records in the U.S., these are really a mess. All the property that we have, our travel, our movements, our financial records, all of these things are, for the most part, tied up. I am getting one spam call after another. Forgive me. I don't know how to turn these off. But my apologies for that. Okay. And I want to make this as clear as I can, and I'm having trouble doing it. But the data that comprises our lives that we really need in order to do good AI on our stuff, that's an internal view. The view we have right now of AI is an external one. It's us in the world. And we think a lot about how are we going to deal with the marketplace. We are not in the marketplace most of the time. Most of the time we're sitting at our desks, we're on our phones, we're with each other, we're not out buying anything. You know, we're buying stuff a fairly small amount of the time. We're relating to businesses a fairly small amount of the time. We are running our lives 100% of the time. If we want to know who is it, what was the last time I was at this restaurant, who was I with, you know, I keep track of that with something called Swarm, which is probably going to die. It came out of another project that, but I have 15,000 records there of places I've been since like 2008, and that's probably going to go away. I want that data, and I want that data to be integrated with my schedule and many other things. These things are not together right now. Our subscriptions are a complete mess. We need to get on top of those. How do we get on top of those? We got to get the data in. It has to be ours. But where I'm going with this is that we really need to have control of the data in our lives. And some of this is going to be very adversarial, getting that data out of the televisions that are narking on us all the time. The apps on our phones that are telling Google and Apple and Microsoft and others where we've been and where we're going on our maps, but don't give us that information. When we fly, where do we go? These are KRL or KML, I forget which they are, files that you can actually get online. You can see what the routes of planes were, but we need to be able to integrate that data in ways that we can make full sense of our lives. So basically my point here is that we need to be, we're not going to have full personal AI until we pay full attention to and get and inform ourselves with the data that is not entirely under our control yet. And so anyway, I've written a lot about this. It's in this series. If you scroll down here, there are now, let's see, 13 things that I've written about this. Almost all of them mention Kauai and what the challenges are here. So I'm going to cut myself short here and give other people, get the next person to come on too early so they're as unprepared as I was because I thought I had another 10 minutes. Anyway, can we do Q&A? Is that a possibility in the 10 minutes that I've just taken? Yeah, thanks.
Brad.
And Dan, by the way, I really wish I was there.
What is the on-ramp? What is the on-ramp for consumers? We tried this 25 years ago and
Yeah,
no one
there
really
is none.
cared.
We have to build it. It is not there. Every company out there, every piece of software that's being sold, everything that Salesforce is selling as agentic AI. You know, we're agentic now. It's Agent Force. Salesforce is a gigantic company that has like 250,000 corporate customers using one back end to deal with you and me 250,000 different ways inside their 250,000 captive systems. That is not that's a separate on-ramp to all of them. All of them think they're relating to you. They are not. They're trying to control you in one way or another. They want to control your experience. They have this myth that we can know you better than you know yourselves. That's bullshit. They never can. This is, I mean, the ramp is a wall right now. It's vertical. We can build something up against it. I'll go here since I have this up. I'll just go here. Okay, here, this is a piece I wrote. This to me is like the biggest on-ramp we can have. And this is a standard that's in development right now. It's called My Terms. It's IEEE P7012. I'm the chairman of that of that working group. And what it is a way to completely turn around the way consent works online. When we get to a business, we tell them, here are our terms. And you sign here, and we both have a copy of it. TCP/IP, HTTP, FTP, all of these base level protocols that the internet runs on are peer-to-peer. They are not top-down. They are peer-to-peer. We can be peers on the internet. We don't have to be subordinate parties that are operating on an industrial model as a whole that assumes that the only contracts can work online is if companies force all of their customers to agree cohesion, which are ones that they could, and we have to just put up with. We can completely reverse that, and we can do it in a way that's trusting. We can come on and say, we can, and this, by the way, is built to run just the same way that Creative Commons runs. Creative Commons runs. We have a nonprofit called Customer Commons. That'll be where like 10 different agreements will sit, and the agreements will say things as, you just don't track me out of here. Or, you know, I'm okay with having my data used in an anonymous way to inform AI. Or I don't want that. But a few basic small switches, and there can be agreements that, for example, almost everywhere you have to agree to terms. The terms are, you know, they're 10,000 words long, but they say a few basic things. We can say to them, you know what, guys, no, I'm not gonna look at porn on the plane, or I'm not gonna do video on the plane. I don't have to click anywhere. You already know. We both agreed to it. We both have a copy of the contract signed here. And your machine can sign there, and our machine can sign there, and we can have AI on both sides doing that. I think P7012, my terms, is the most potentiated thing we have in the world right now. Anyway, that to me, that's the on-ramp. But we need a real strategy for getting this going. It involves funding, especially for customer comments. But I'm optimistic about it. I think it'll happen. Another question. We've got another 5 minutes.
Thank you, Doc. I checked the schedule. We have 4 minutes left. Any final question for Doc Searles? Yes, AZ. Doc, the question was, will translating all of your content that you're presenting here at SCaLE into a personal AI assistant solve this problem for you?
Sure. I mean, it's...
from Swarm, all of your content from Swarm, will that solve this?
From Swarm? No, well, yeah, sure. It'll partly solve it. You know, if I have if I have an AI, and I don't think it has to be a chatbot or an assistant. I think it could be a view. I just want to see this view. I mean, in many cases, I am going to want an assistant. But I think the primary model we have now, and we've been working on, I'm not criticizing it, but I think it's a limited one, is a Q&A one. I'm not doing Q&A when I open a spreadsheet. I'm not doing Q&A when I look at next of a book. I'm not doing a Q&A when all I want to do is look at a table of, here are all of the subscriptions that I have and when they run out. Or another table that has here's Paramount Plus and Disney and Netflix and Apple and all of the other stream services that I've subscribed to, and what did I see on those? I don't want to just ask something that I can see them. I could see a list. Here's the list. I'm going to reorder. What did I see most recently? When did I drop out of that one? Some of this is Q&A. Some of this is just a table, a list, a database query. The the key thing, and I was talking to Steve Vitka about this. I don't know if he'll address it later on a call last week. It's the data layer of this that we need to pull together if we're going to have truly personal AI. That is the AI that we use to get on top of our lives in the digital world. And getting that data structure together, pulling in data from lots of different places. I'd like to be able to take my phone, look at my bookcase over here, imagining it's full of books, which is not there in the other house, but look at the spines of all those books, which ones, tell me what they all are, put them in this database. Where are these books? I live in 4 different places, by the way. Sounds much fancier than it really is. But, but I would like to be able to look at the bookshelves in all 4 of those places. Where is my copy of this? Is it that one over there? Is it here? I'd like to know this stuff. There's so much in our lives that we do not have control of, and we aren't going to get in control of it as long as it's sitting inside the corporate databases that are kindly maintained for us by, say, Microsoft and Apple. We need to be in control of it ourselves. So that's basically it. And I'm probably out of time.
Excellent point on the interface there, Doc. We've got time for one final question for Doc, if anyone's got one. We got one.
Good, I felt like I caught a fish. I caught a person.
The question is, most users are interacting with this stuff on a mobile device, which is inherently not open and rather limiting. All of these sources of data are distributed. What are your thoughts on that? Did I get you right? All right.
That's a great point. I think one of the slides you didn't see that I didn't get up, but maybe I'll put them all together later, is that your personal AI should be as personal as your pants or your PC. I have a sense that this PC that I'm using right now is mine. I don't have a sense that my phone is mine. My phone is Apple's. It's not mine. It belongs to all the different apps that are on there. I actually think, and Ian Henderson has some thoughts about this too, we're going to need another device. But probably a portable device, probably a small one. But it could be a tablet. I would think it's Android-based or non-Google Android-based tablet or phone size thing that has our data on it and our apps for operating on that data. I think it should have a Pi OS running on it that is our OS that has our data on it and can interact with the phone or interact with the PC, but it'll be ours. It'll be a secure place that is ours and it's separate from the Apples and the Googles of the world because they can't think outside of their own siloed structure. I mean, their paradigm. We need it. I think we actually need a new device paradigm in order to make this fully work. And the other part of that device paradigm, of course, is the network. I mean, I'm talking to you right now over a 2 gigabit community symmetrical fiber system that we just got installed by the city of Bloomington, Indiana. What if everybody in the city had, a $200 device for storing their own, for doing their own compute cooperatively? Basically the QuiNet thing. We ran QuiNet here. I think it'd be really awesome to do. There are a lot of small towns like this that are doing really leading edge work in fiber where we could share resources. Anyway, I think we need a couple of new paradigms, one network, one personal, for the devices that we need to interact with the world. The PC is stale. The phones are owned by 2 big companies, and we need to think outside both those boxes.
Thank you, Doc. Appreciate it. And thank you to the questioners in the audience. We're going to move on.
And I so wish I was there. Somebody raise a glass for me tonight.
We'll see you next year, Doc. Thank you.
I hope it's sooner. Okay, take care, everybody.
Wonderful. It is my pleasure to next introduce our final keynote of the day, Catherine Druckmann. Catherine is an open source evangelist for Intel, who brings together her deep enthusiasm for software security and emerging AI technologies, brings together her deep enthusiasm for software security and emerging AI technologies. She chairs the OPEA Security Working Group, serves as co-chair for OpenSSF Marketing Advisory Council, and contributes to the community building and developer relations. A longtime advocate, developer, and podcaster in the open source space, she currently hosts Open at Intel and co-hosts Floss Weekly and Reality 2.0. Adding to her extensive experience from over a decade at the Linux Journal, she used to work with Doc. Please join me in welcoming Catherine Druckmann for her talk, The Freedom to Create OS Frameworks as the Foundation of Personal AI. No, please. That's a waste. We can go audio only.
Hi. So first, I have to say, before I get into all these lovely slides that we'll get to in a minute, how excited I am to follow Doc Searles. We've been co-conspirators on so many things in the last, oh gosh, I don't know how many years. I was at Linux Journal alongside him for 12 years. We continued our podcast after Linux Journal effectively shut down. That's a long story, but yeah. So we've done so many things together, and to finally be able to be listed as a keynote speaker alongside Doc is exciting because frankly I am a student of Doc Searles, as are we all here, I think, right? Or we all should be. So this is pretty exciting. But what I'm going to talk about is, we've talked about so many big ideas already today. We've heard from Bruce Schneier, we've heard from Doc, we've heard from others. Oh, thank you. Yes, good reminder. Yeah, I really got to stick this one right up there. So we've talked about a lot of big ideas, but how do we get to those big ideas, right? I think we're all here at SCaLE, Southern California Linux Expo, for a reason. I'm gonna kind of make the assumption that we're all open source people, or I hope we are. But open source is really the way that we're going to get to meet the goals that we're talking about. The personalization, the personal AI. So we're gonna talk a little bit as soon as we figure out the slides. As soon as I figure out, as soon as everybody figures out how my laptop works, including me. Yeah, so we're going to talk about it. We're going to talk about why that's the answer. But we're also I'm going to give you a little preview of a project that I'm working on. I am actually co-chairing the security working group for a project called Open Platform for Enterprise AI. It's an Intel-created project, but it is not an Intel project. It is now under the Linux Foundation's AI and Data organization. It is very much an open source platform. So I'm gonna give you a little walkthrough of it. And then honestly, I'd really love you to all join me in that project, because this is exactly the community that I would love to see more plugged in, to have these important conversations, to have the conversation about how to build trust, to have conversations about get what we need out of these applications, not what somebody else wants us to have. So I'll get to a QR code eventually, and so you can find it. But the project is, you can find it on GitHub. It is called Open Platform for Enterprise AI. Under that GitHub repo, you can find, or under the GitHub account, you'll find a repo for the security working group, and I will continue to shamelessly plug tough conversations about what all of this means and how to make sure it is secure and trustworthy. We're almost there. It's cool, this means I can fly through my slides. Yeah, really quickly so that I know what to do when I get to this section of my presentation. If I say a RAG application or a RAG technique, how many people know what I'm talking about? Okay, so most of you. But some don't. Okay, that's good too. See, I never like to assume that people know the acronyms that I'm throwing out there. Yeah, it's the opposite. Can we just say switch? Yeah, so when I get there, I'm going to do a quick little demo of what RAG means. So, just to make sure we're all on the same page. I forgot my cat ears, so you're going to have to, I know it'll make sense in a minute. You'll just have to picture me with cat ears. We're still figuring it out. There we go. Oh, we got it. We got it. Okay, we got it. Let's go back to the. Why isn't it? Why do I still have this? I don't know. Sorry, one sec. PowerPoint has tried to take over my laptop. See, this is what happens when we don't get AI correctly. The machines take over and ruin our lives. I agree. That's a whole. Unfortunately, this is the world I live in. Oh, there we go. Yeah, it's we're just gonna keep going. It's fine. Oh, there we go. Okay. So, I've already introduced myself. We're good. So let's just quickly, recap. Not that long ago, we were all dreaming and chomping at the bit about the great economic impact that generative AI was going to bring to us, right? Goldman Sachs predicted it was going to raise global GDP by 7% over a 10-year. Thank you for that reminder. McKinsey just published a report. The impact on productivity is going to add trillions of dollars. It's all very exciting, right? But let's talk about the whole AI revolution and how we got here. So generative AI development is not new, is it? No. But in the last several years, things have moved pretty rapidly. Learning models were the big leaders when Google published the transformer architecture. quickly realized how powerful that was going to be for natural language interaction. And then we started seeing this explosion, right, of models and frameworks. But really, what is the cost of all of this? The cost is fragmentation. The cost is everybody's kind of doing their own thing. We're working in silos. We're not necessarily working together. We're not necessarily working on what the best way to do a thing is. Because we all want to come up with our own solution, own the data, own how it works. Again, as we've just seen, innovation rapidly. Everyone from large enterprises to small startups, individuals, developers, incredibly excited to jump in, reap the benefits of generative AI for productivity. Show of hands, who's currently developing generative AI applications? Anyone in the room actually working? Fantastic. I hope that. But with so much excitement, right, comes a few challenges and even hurdles, and I'm going to talk about that. Some of the problems that rise from this kind of rapid innovation, and when you're a pioneer in any given technology. Those of us in this room can agree that we're not willing to let our desire for respect for users, for privacy, for individual agency, our own data, we're not willing to give that up in the interest of rapid innovation, right? Frankly, I keep waiting for a truly useful AI tool that will do my taxes. I don't want like a cute chat bot asking me questions about my finance. I want something on my computer that can just figure it all out. But I don't want anybody else to have that. I want it to be mine for my benefit alone, right? I suspect I'm not the only one, right? I don't think that's too much to ask, right? Keep my information secure and private. But if we don't proactively make the choice to choose the open ecosystem, the open source way, others choose for us. All of the things we've talked about thus far this morning are impacted by this choice that we make to remain open and committing to fostering, contributing to, and participating in open ecosystems, open organizations, and open source. This is how we achieve our goals of avoiding vendor lock-in, right? Supporting and fostering an environment that is set up for innovation, real innovation. Our goal of protecting our data, benefit from, and this is a really important one that often gets overlooked, but benefiting from the wisdom and support of the ecosystem's community. Future-proofing your applications, right? Protecting your ability to stay agile with your development choices. Swap out what's not working. All the way to the trust that Bruce Schneier just talked about, and personal rather than personalized AI that Doc just mentioned. And frankly, it's probably going to be cheaper if we keep it open. If we keep it open and we maintain our freedom to pick and choose what we want and what we don't, any model, any data store, any framework. This is how we make AI applications we want and need them to be. So when we're focused on rapid innovation, right, especially in pioneering fields, I love to use the word pioneer because that's what we all are right now. We're at a weird point of inflection. We may be focused on a goal, right, getting out some kind of minimum viable product. I think that's probably where we've all been there. Getting some functionality out the door. But I think what's sometimes lost in that drive is the foresight to apply principles that lead to interoperability and flexibility. In emerging fields where best practices and modular architectures have not yet been established, like where we are kind of right now, that lack of established best practices and standardization slows down development processes. AI development is really kind of like the Wild West. Everyone's reinventing the wheel, to a large extent. So what I would like to see, we would like to see, as in part of the communities that I'm a part of, is establishing community-established standards to kind of smooth and speed up everyone's developer workflows. I think that is part of how we get to meeting all of these audacious goals that we've talked about so far. And again, it's the open source way. We come together to establish the best way and the vendor neutral way. So what happens, right, when we get excited and we push these technology boundaries? As much fun as we're having creating this new stuff, we tend to focus on the end goal and getting there by any means necessary. That can mean we're constantly reinventing the wheel, not the open source way. But we are breaking a lot of new ground very quickly, and there are a lot of different options and paths to reach the same goal. And because we have so many options, we may end up like this pile of disorganized Legos. That's my choice of image there. Without a reproducible way of working. So, but as a community, again, I think we can do better and benefit from what we're all learning in our individual silos and bringing it together to forge a more standardized path. So this is I made this with AI. I'm sure you're shocked by that. So I made that was an AI generated image. So this represents our current minimum viable product. It works. It maybe even works well. It was probably really fun to build. Maybe, hopefully. But it might be tough to modify. Might be tough to expand. Might be tough to maintain. You might have created a monster. But if you had started, we're getting to this project, right? If you had started with something a little bit more solid foundation, maybe you would not have built such an unruly monster. And it wouldn't have the mind of its own. So, with the struggles that organizations and developers face under the pressures of rapid innovation, being mandated to sprinkle a little AI on it, I think in many cases, it might be tempting to take the proprietary path, or any path of least resistance, but we really don't need to. So the good news, the open source community has come together as we do, right? In this case, under the umbrella of the Linux Foundation that I mentioned earlier, under the LF AI and data, to work toward the standardization that I think I mentioned that I'm hopeful for and that we all need. An interoperable vendor-neutral platform that helps us tame a bit of that chaos. And that is the open platform for generative AI. So, again, as enterprises try to achieve their AI goals, they're looking for simplicity, but so are the rest of us. Simplicity and total cost of ownership savings in their deployment. Being open is the key, I think, to having control over what you do. Better collaboration, right? Starting with a more standardized architecture saves you time and effort down the road. Anyway, moving along. How much time do I have? Okay, yeah, we're gonna start speeding through this guy. So again, I'm from Intel, but this is not an Intel project. We have many co-conspirators collaborating on this platform. But I wanted to quickly go through what is RAG, and I'm going to speed right on through it because I don't have a whole lot of time. And then I want to show you some basics of the architecture and how you can easily build a chat app, for example, using, again, an open platform. So RAG is retrieval augmented generation. Really quick demo. What does that mean, right? If I ask a chatbot who my mom is, it doesn't know, right? It might know a famous person's mom, but it doesn't know mine because it just doesn't have that context. But if there's the cat ear thing. So, a model is not smart. A model is just pre-trained with general knowledge. So, but if we provide it with context, it might give us a better answer, right? So, again, speeding through the slide a bit. If you provide context, a chatbot could generate a response based on a novel topic. In this case, somebody's mom. If you tell them my mom is 60 years old, my mom is whatever, it can tell you, okay, well then it'll tell you the information. And this is RAG in a nutshell. The main goal of RAG is to provide a prompt with enough context so that the LLM can generate an answer based on the information provided. So I want to break down the interaction just a little bit, right? This is a complex series of events leading from that question to that answer in this case. And this is, kind of a general outline of it. Think of it as a two-step process. First, you need to pre-process and store your knowledge in a knowledge base. For example, if you ask, who is my mother, the system will search for relevant context to answer the question. To do it, an embedding model converts the text of your question into numerical vectors representing the meaning of the text. Then the retriever compares those vectors to the vectors stored in your knowledge base. The vectors are meaningful, and we can compare them to find the most similar documents. Once the system retrieves that relevant information, it can then re-rank the results before So we can assume that this is going to be complicated, right? But there are some challenges of RAGs. You know, many LLMs. How do you choose what model to use? How do you deploy it? What guardrails do you have in place? How do you ensure the accuracy of the results? You know, how does this all even work together, right? So, but if we start with a stable framework, a composable architecture, this is the aim of the OPA project, right? Create this solid foundation on which to build applications. OPA provides a reference architecture. All of those Legos that I showed you before are microservices that can be easily plugged and played and give us this solid foundation. We also have a mega service that works kind of nicely together to interact with the user interface, and that all leads to faster development. I'm going to skip the demo because we don't have time, because this is basically just a chat interaction. So here we see that each separate microservice is, again, designed to work together to serve various functions in this chat Q&A application. This, again, is one reference architecture of 22 as part of the OPA project. But this is just a really great example, right? A chat Q&A bot is something that a lot of organizations, a lot of people are trying to build because there's a lot of great applications, a customer service application, and you need to feed it that additional context. In this case, we have a user interface and the data supplying it, and then the microservices, again, can point to other services and APIs, and then we'll break that down just a tiny bit more. I'm going to skip showing how the embedding microservices works. But here's basically the larger picture of how the microservices interact, how they can communicate with each other. But there is still something missing. This needs to be able for human use, and that is the mega service. This is my favorite slide because it has the animation. The benefit, again, of grouping these microservices in this way provides a communication gateway between the mega service, the group of microservices, and a front-end UI, which then gives you a full application that actual humans can use. We do not expose the individual services to the UI, so it provides communication to the UI and handles communication among the various microservices. So this is just a quick demo of the kind of thing that you can build with the OPA project. This gives you a blueprint to build on top of this set of microservices to create whatever kind of chat Q&A you might need or want. But it's not just limited to that. There's visual Q&A, there's code generation, there's translation, there's a lot of reference examples. But anyway, this is what we're working together to solve. We want to put, again, power and flexibility into the hands of the developers that are working to build these kind of generative AI applications. And I would really love to see some contributions. I would love for all of you here to join us, and join me in this. And again, if you don't find what you need in the repo, please work with us to create And then again, neutrality is the key. So we need that flexibility in building our applications. I'll get to the one last really important thing. There we go. Lots of ways to participate. Please scan this QR code. Please check out the project. Please join us. Build all the things. And build them the way that you want, not somebody else wants.
Thank you.
Thank
Here,
you.
here.
Thanks for bearing with me while I sped through this slide.
Build them our way. I love it.
And there's one final.
Oh.
Sorry, I gotta plug my podcast.
Plug it.
That's where you can find me. Thanks.
Sweet. Thank you so much, Catherine. Thank you, Intel, for your sponsorship. Really appreciate everyone hanging in for the keynote sessions. We're going to head to our first panel. I'd like to invite Fayez Ramandi, Catherine here, as well as Ruth Rasool up to the stage to sit here on the first panel. Riza is going to be moderating the panel, asking a few questions of our esteemed panelists here. Yeah, you can keep your mic there. Lunch break? Who needs lunch? You know? We're packed content. You know, feel free to come and go as you please. But yeah, we're packing all the content in today. So. Come over to the Twilight Party. We'll have some heavy apps, the heavy type, over at the Twilight Party over the Hotel Dina. Do my best.
Are we good? Are we good?
Karaoke
Is this working?
to really get in there.
Is it me you're looking for?
I feel like the Supremes or something.
I can see in your eyes. I think so.
Hope
Who's
not.
playing the music? Somebody. What's that? Here, YouTube, if it works. We don't have connectivity though.
So is it just the two of us in the hot seat? Because there's
Ruth is sitting, I mean, this is the light issue. They updated that too.
hello. I do enjoy an all-women.
Hardly
So,
ever.
so microphone 101,
Yeah.
the sensor's right at the bottom of the microphone. And it doesn't work when you wave it around. You're actually talking right down to the bottom of the cylinder like that. And so you don't have to talk very loudly in order for audio to come through. So this is an example of mansplaining.
Thank
And
you
I've
so
got an
much.
audience and I'm standing up, so I'm in my power position. But I'm going to step away.
Manspreading.
I'm going to step away to just anticipating the onslaught of yeah. So look, I I asked my favorite AI, which that changes every week because a new AI is coming out. I asked for some questions because I'm a moderator of this panel, and I asked, can you create me some questions that would provoke a conversation around personal AI? And you know what? It came up with a dozen questions that were really vanilla and antiseptic, and I threw them out. And I thought we just have a conversation from the perspective of people that have got some seniority, that have seen the evolution of the computer science. Thank you. Okay. that I've seen the evolution of the computer industry, and I'm seeing it in as a pendulum swinging. When Doc Searls was talking before, he talked previously on previous calls about AI being in its mainframe phase. Mainframe where computing is very centralized. He said if you think back to the 1970s, computing was a mainframe phenomenon. It was a mainframe prospect where if you had a job to run, you'd run it on a batch processing, on a time-shared computing service like your payroll, and it would come back. And then along came the personal computer. And if you'd ask people in the 70s, hey, do you want a personal computer? That would be like saying, do you want a personal nuclear reactor? It was just unconceivable until it happened. And then within less than a decade, we had computers on everyone's desk, and there was an explosion of innovation. I'm seeing the pendulum swing, and I wonder if you have a perspective on where we are in the swinging of that pendulum from mainframe to personal, back to mainframe, and where are we in the AI context? So let's take it from Catherine. You've just spoken, and do you see us moving to more centralization, or do you see us moving to more distributed AI?
That's a really good question. I feel like those are where I don't know that it is a pendulum. I feel like they coexist and are in constant, like a tumbling, brawling. I wouldn't say it's a fight, but it's a dynamic, cyclical relationship but it's a constant motion, right? You know, it's not, to me, it's not that sort of linear representation of a single point along a spectrum. To me, it's a constant rotation, a constant coexisting, or maybe we're in a tornado of AI. I don't know, because I don't think it's so cut and dry as to say that we're on a single point on a linear scale between the two.
Okay, thanks. Faye, what are your thoughts on where we are?
Yes, tend to agree. So I think you have to look at the computing evolution itself. It was mainframe, then it became client-server architecture.
Right.
Then it was VMware virtualization. Then it was compute. Let's build a data center where the compute is, because these devices were dumb and didn't have enough compute. Now we're reaching a level that computational capability is going up from CPU to GPU to memory to, microcontrollers. Everything has compute. So with that in place, obviously, you have to say, okay, my software construct will need to change because I don't need to host software in cloud anymore. I can actually host the workload on where the compute is. At the same time, we have to look at how the traffic patterns have changed. If you look at the first generation mobile internet and browser was about, I'm gonna go where the content is and consume the content. I'm gonna go watch a video. I'm gonna go watch, consume information. But now these devices generate traffic, they generate information. You're just capturing video to broadcast it. You're going to take a picture and share it with somebody else. So the data source and traffic pattern has changed to device generating information. And now I have enough compute. Why shouldn't I be able to process that data right there and extract knowledge right there? So it's not about a pendulum of movement from back and forth. It's about the evolution of compute, connectivity, and information. Therefore, it's moving to the hybrid.
Right.
And again, it's about hybrid versus one over the other. I'm not a big believer of full decentralization. I'm not a big believer of anarchy. I'm a big believer of a small government, autonomy, but you have some global, again, framework of policy, regulations, and things like that everybody need to abide by. Otherwise, we're going to have a chaotic world.
Okay, Ruth W.B. Yates.
Yes, the center cannot hold. Things fall apart.
Right.
But I think what you're thinking of in terms of a pendulum, maybe the pendulum is the public acceptance of the personalization or the invasion of the compute power. I'm thinking of it in terms of in education, whether we accept the personal capability. Outside we were talking about having spoken with Nolan about education and AI, that we maybe maybe a pendulum is the right metaphor. I'm not sure, but we're at the point where we're being forced to accept this
adjust the gain on your microphone because you're not holding it close enough.
Yeah. I don't want to hit myself in the face because I know that my hand's going to keep moving. Just move this one.
Okay.
That we're having to teach students with that AI capability, just in the same way as we, back in the mainframe days, just as we had to teach them how to use the internet, just as I was talking to a librarian outside, just as we had to teach them library science and research. So probably it's more of a maelstrom that this thing is, we're in the center of it, and what does fluctuate is the acceptance of it.
There we go. Okay. So we've had the gain turned up on all of our microphones now, just to accommodate.
We need AI to
We do need
just adjust
AI.
it dynamically.
AI should be listening now. Now I'm going to hold the microphone further away. Okay, so you touched on a point, and a lot of the conversation you've had today. When in fact we were speaking with Nolan, you were talking about AI in education, and AI. You've got some experience of trying to introduce AI into your classroom. Perhaps you can talk a bit about that and describe that to everybody.
Yeah, and that's again a conversation that we were expanding outside, that if you create, like Kwai created an assistant for me that is trained on my course content. So that's a useful product for my students who are not, when we were all in college, except you maybe, it was the older generation, when we were in college, it was a 9-to-5 full-time thing. The students that I have now in online classes have full-time jobs, full-time family commitments, and they're full-time students. And they have to pack that all into a 24-hour period. So they need access to course content at 2 a.m. They need to be able to ask questions at 2 a.m. If there is an assistant that is trained on accurate data, such as what do I need to, what is the first paper about, what do I need to study for the first exam. If you ask ChatGPT that, it won't know. It will give you an answer, but it will be garbage. So we need to have that more personalized, accurate information.
I want to ask a question.
Yeah, go ahead.
Actually, around this on your list. Yeah, I'm sorry for those. I mean, I don't want to spill the beans, but it's one of the. I'm a movie buff and documentary buff. These are the two things I love. Subservient is a movie about a personalized robot that when you buy it, it's so focused on you to do what you wish to do. To the point that at some point it wants to kill your baby. And it calls it the little problem. So the question is, what do we mean by personalized AI? To what degree this personalized AI know about me? And do I really want that level of personalization that it knows deepest, darkest point of my mind that even I don't want to look at or I don't want to know. So what does personalized AI really means?
Okay.
I think it's, I mean, what we really mean is that we set our own boundaries, right? That those boundaries are individual, right? So we can, the way I see it is I want AI tools that will do everything I need them to do, but absolutely nothing that I don't need and don't want. And I think that's the struggle. The struggle is that we get easily trapped into using the tools that somebody else thinks that we need, right? And then it has the functionality and shares what it wants versus what I want to.
The problem is that majority of time we don't even know what we want. We don't know what we don't know.
We'll have to ask a chat.
And then the moment it comes, you don't know whether, oh, shoot, I don't want this.
I like to think the boundaries, I think that's a little bit easier. It's kind of like, rather than defining a list of feature requests or what it is that are desires, I think setting boundaries and allowing the marketplace or developers or whoever's working on tools to suggest to suggest that I might want a tool to do X, Y, and Z. But I think my ability to say, okay, but up to this point and in this way, and that's where the freedom and the kind of personal agency comes from, I think, is the ability to set boundaries. Not so much to set requests.
But do you consider personalized AI and boundaries as one thing or a collection of based on at any moment on what I want?
Oh, that's a good question. I mean, we are humans, and what we want does change from moment to moment. So
Exactly. So it boils down, to systems that are flexible enough and interoperable, and you can wipe out whichever linkage that you don't want to have.
We don't just need to define what personalized is, but we need to define benefit and usefulness, and that's how we make those decisions about what's beneficial to us or what is intrusive.
Exactly, and what's beneficial to us could change and could be starting with simple things. I use map wherever I go. But the moment I'm about a mile away from my home, I stop the map because I know the rest of the way.
You don't need the map to tell you the 5 turns to get out of your driveway.
But the map never learns that from me. And it wants to continue working until I manually turn it off. Every time it gives me suggestion for a path, I take a different route. And it doesn't learn from me. To say, okay, next time is Faye. I already know she entered the car. It's her phone. It's connected to my Bluetooth system. Let me take the route that she wants. So it can start from much more basic, functional, practical way than jumping into know everything about me. And I think if we start with those meaningful, pragmatic steps in a proper software construct and structure, then the personalization could become the outcome. Versus personalization be the first one to start with.
What do you think about it, Catherine?
Well, I think in terms of the same, so we all approach this from our own unique perspective and set of experiences, right? So when I think about this question of what does it mean, right? What does personal AI mean? I think of it in terms of things like trust and safety and things like that. It's about comfort level.
Yes.
And so I think of it in terms of guardrails, right? You think of it in the same way that you talk about putting guardrails into applications to guard against unsafe responses and prompt injection, whatever it is that we're trying to guard our applications from. I think of applications that respect me as a human in the same way. So setting up my individual guardrails.
We've been debating this within Quai for the last 2 years, year and a half, to come up with what is a definition. And you heard Doc Searls talk what's the difference between personalized and personal AI or personnel AI, which a lot of vendors are actually creating. 3 things. One is focus on individuals' problems rather than the enterprise problems. That's a focus, it's a choice. The second is it's an architectural choice of moving systems from centralized control and devolving the control and allowing ourselves to know ourselves a lot better. And third is alignment. I think it's what you're talking about of trying to make sure that the motivations of the technology are aligned with our values. And it's an agent for us, a loyal agent, not a double agent working on behalf of corporations. What are your thoughts on
world where the interests of the individual coexist with the interests of the enterprise, right? We have some similar struggles, and I think we can, all of our needs as individuals as well as the enterprise needs. And again, I preach the gospel of open source unnecessarily because of where we are, but as individuals in communities like this, where we are right now, this is how we influence the enterprise. This is how we influence others to create the things that we want by setting up, by influencing projects, by showing up, right? Showing up at working groups, influencing projects, but also influencing the direction of the industry. We have the ability to influence where this is all going and make certain demands and come up with solutions that enterprises then adopt and we reap the benefits of. That's kind of, I don't know, that's my hope.
So in the final question, there are a number of organizations like Quai that targeted the year 2030. So there are organizations in climate, there's the UN 2030 initiative, they target 2030 as a key date. I was drafting a blog post at the beginning of this year saying 2030 is 5 years too late. Can you think of what do you anticipate our industry would look like 5 years from now in 2030? What is your crystal ball gazing? What would our society be like? How would we be using this technology?
I think we're exactly at that junction of a dystopian future or utopian future. And I think the issue is bigger than, I want to touch on corporate enterprise versus personal.
Okay.
Are you a corporate or a person? At any moment your role changes.
Yes.
Quai as an open source organization, Reza as a founder.
They don't even use it at all. I think it's 50% of the population knows what ChatGPT is, something like that. Probably has grown since then. So with that being said, I think it's always interesting to see, we have law practices and big financial corporations coming in and willing to learn how AI works and adapt to the workflow and learn what is required to train these models and perform these tasks in order to get the outputs they're looking for. So that's always surprising to me, just seeing that.
Fascinating, thank you. John, let's start with you on this one. Any words of advice? You've been given a lot of these. Any words of advice for the engineers, the designers, the entrepreneurs who are building AI applications?
Yeah. This is the era where you can build a 4-person unicorn. And I'm not saying you should, but if you do, get a hacker, hipster, and hustler to support the visionary. And the hacker is the technician, the hipster is the design mind, the product person, and the hustler is the biz dev. Surround yourself with talent and help your team make each other better. Catalyst. The CEO catalyst.
Nice. Liam, how about you?
I would just say, experiment, try new things. Don't settle for the tools you're using. There's probably a better one you don't know about. If you want to be pointed in the right direction, reach out to me. But I'm finding three things a day, constantly replacing my tools, and you should too.
Caitlin.
Yeah, so I would just say, don't be afraid to try new things. Even if you're not super technical. I actually have a sociology degree. I did a complete 180 after college, realized maybe the last 4 years wasn't what I wanted to be doing, but so I would say don't be afraid to explore and try things out and try different tools and see what works for you, and maybe it doesn't work for you and that's okay, but we're all figuring out as we go, so.
Hold on, Soch major. Yeah. Greg.
Find a community. Find a community where you can explore, experiment, join Quai. There are precious few thought leaders that can really teach you about AI. It's changing rapidly. So you can only learn by doing, and you will become the thought leader. And as a part of a community, you could learn from others who are just a little bit ahead, because there's not a lot to be ahead. And you can be a thought leader for others as well.
Thank you. What a great community note to round out on. We've got about a minute left, and so I'm going to offer your 30 seconds for, I guess you get 15 each. I'm going to offer your 15-second. What's your closing note here for the folks in the audience? I'm going to kick it off with you again, Caitlin.
I wasn't prepared. I would just say, I'm just really emphasizing, go out, explore, try new things, figure out what you want to do, whether that's, maybe build on top of AI models, use it, within your device, hosting locally. Just see what you can do and what you can leverage in different aspects of your life. You might think it's a simple task or something that maybe doesn't make sense, but try it out. There's so many different things you can use LLMs and personal AI models for. So just give it a try.
Liam.
I'm just going to have a shameless plug for our sister community. Come join us at companionintelligence.com. A lot of the same people you'll see at the Quai group or IIW or elsewhere. And we're also an open collective of code doing several interesting things. I could shout out to the just in case backup that we're working on, which is a open disaster data set that anybody can back up, including Wikipedia, disaster journals, all sorts of things that certain governments might delete off the internet one day and things like that. We're doing to try to not just have open AI, but open data that powers it and all sorts of other things. So companionintelligence.com.
John.
Prepare yourself to have more power than you have today. In however you prepare yourself, whether it be with AI or through community building, be more powerful.
I have a plea. Please, please don't cede this new technology that will be more powerful than anything we've seen so far to the same smug bastards who have ruined technology for the world. Take it, build on it, do not let them take it over, because they're going to use it against us, just like free and freemium has been used against us. And those blind boxes or whatever they're called in gaming that have exploited children, don't let them do that with this technology. This is way too powerful.
Hear, hear. Thank you to all of our panelists. Really appreciate all of the effort. If you could switch your mics off, I'd appreciate that too. Sorry about the levels. I've been back there tweaking dials that I have no idea what they're supposed to do. So at this point, I don't want to touch them too much more. So thank you all. Really appreciate this. We're going to move into the AI research selection of talks here. We've got some more folks from the Quai community that are going to be coming up. Our first research talk is a virtual talk. And so we're gonna try this again. I see Diego here. Hello, Diego. I think you can hear me. I'm gonna go ahead and get you pinned up. Diego, let me get you an introduction here properly. Oop. Dr. Diego Galeano is a machine learning researcher at the Faculty of Engineering at Universidad Nacional de Asunción in Paraguay. His work centers on advanced ML models for drug discovery and medicine, including predicting drug side effects and designing pharmacological countermeasures against the adverse impacts of space radiation on human health. Please join me in welcoming Dr. Galeano, joining us live from Paraguay for his talk on GraphRAG and RAG frameworks for accurate drug side effect retrieval in LLMs. All right, Diego, take it away.
Yeah, hi Matt. I will share my screen. Just give me a second. Okay. Can you see my screen?
It's coming up. Here you are, go ahead.
Can you see my screen? Can you hear me?
Yep, we got you loud and clear and got your screen. Thank you, Diego.
Oh, fantastic. So thank you so much for everyone that joined this summit of Kwai. I am Diego Galeano, and I will be presenting you the work that was done by a lot of people in the AI for Life Sciences group at Kwai. It's a small research that we have carried out last year, and it's about RAG and how to use RAG and GraphRAG frameworks for accurate drug side effect retrieval in large language models. So let me start by the motivation of this project. Oh, I don't see the slides moving. Okay, can you see the slide, the second slide? Okay, no, it's just
we have motivation.
Yeah, perfect. So basically in 2023, when ChatGPT was around the time that ChatGPT was released, what people realized is that these LLM systems were not accurate at giving you information about drugs, drug effects in general, but also for medical questions, for answering medical questions. And so we basically posed to try to answer also these questions onto whether large language model, how accurate they are for certain type of information, and also how can we fix this issue. So the research question was, how accurate are these large language models at providing information or prediction about side effects of medication? This was the initial research question that we have. So to answer this question, we need to look into some database that give us information about side effects of medications. So why we thought about this problem is because people are gonna use like ChatGPT or any other LLM to ask about side effect of their medication they are on or they are taking. So we thought this is a very important problem, and that's why we started working. So just a very brief recap on side effect dataset. This is a publicly available dataset that is called CIDR, and is usually collected on clinical trials. So the initial part of this research was asking what happens if we simply ask like ChatGPT or another LLM about drug side effect associations. We wanted to know how accurate these off-the-shelf systems are, right? And what we obtain here is a very low accuracy between 50 and 60%. I think with ChatGPT version 4, this improved to 60%, but still 60% is very, very bad for applications, especially on this domain of healthcare. So the solution was to try retrieval augmented generation RAG, which I'm pretty sure you are probably very familiar with. So the idea is that you need to transform your raw data set into some text format. So basically here you see some illustration of the database. We have some text formats of the drug side effect information. Then this needs to be stored in a vector database by splitting the text into several chunks. This is done using some embedding technique that we try, and the vector database that we use is called Pinecone. So finally, once you have built this vector database, you can run the queries based on an user. So here, this is the end user that maybe writes a prompt that is this side effect an adverse effect of this specific drug? So we basically build this pipeline, this procedure to query from the vector database similar text. And then based on that, we filter the result and we modify the prompt to inform the LLM whether that is a known drug side effect association. And in this case, the LLM is constrained to provide a yes or no answer. The other idea is to use a GraphRAG representation by representing the drug side effect information as a bipartite network. In this case, we have 0 nodes that represent the drug, a 0 node that represent the side effects, and here the links represent whether the drug is known to cause the side effect. And this graph information can be also stored in a graph database that is called Neo4j. And there is a special type of query that you need to use to load this data set here. And then the pipeline looks very similar to what I shown before. So basically, given an end user that writes a prompt asking about a drug side effect association, we had this entity recognition module. What this does is extracts the term that contains the drug and the side effect. And based on that, we query the database. So basically, you want to know which one is the drug and the side effect that the user is asking about, and then you use that to try to find whether there is a link in the network. And if there is a link, that will be returned here, and then you can use that information to modify your prompt and provide that to the LLM so that the LLM can be more accurate. So how do we assess this system? We pretty much follow the literature on this, and we frame a binary classification problem. And we ask whether this LLM system can correctly detect the presence or absence of drug side effects as prompted by the user. In this case, we had to constrain the LLM system to answer yes or no, because it's a binary classification problem. We just care about that answer. But this is not going to be the case in a real setting, of course. And also to limit the number of trials or examples that we run, because this is computationally very expensive. We had to sample for every drug just 10 side effects at random, and also 10 unknown side effects. So 10 known and 10 unknown. So this was the final data set that we used, or the final set of the data set. So we basically ran this analysis on over 19,000 drug side effect associations for almost 1,000 marketed drugs. And these are the results. So here what you see, just a second. On the x-axis are different binary classification metrics. I don't know if it is loaded yet. Okay, so in the x-axis you see different binary classification metrics. On the y-axis, you see the prediction performance, and then the different bars, the different colors represent the different methods. So the blue color will be basically using a Llama 3 AB LLM without any other information about drug side effect, just asking whether the system knows about drug side effect. And as you can see, for instance, in terms of accuracy, the performance is quite bad, right? Because the system is not good at providing this information. It's answering at random pretty much. But when you use RAG, which we had two variations here depending on the data format that you can use, we see that there is a massive improvement. especially if you use data format B, which is like the green line, because this can also affect the prediction performance. And in that case, accuracy can get pretty much like perfect performance. And this can be improved by using GraphRAG. So GraphRAG is so far the most accurate system for us that we found to for drug side effect retrieval in LLMs. So as you can see, the performance is almost perfect. So there is a small variation. There are some mistakes. And the conclusion for this is that these mistakes are because of some random variability in the LLM. So even though you give the LLM the correct information, sometimes the LLM can still hallucinate and answer no, for instance, or answer yes when it should be a no as an answer, right? So the conclusions of this research is that off-the-shelf LLMs are not factual, so be careful with that, especially when asking sensitive information. They might not know about side effects of medications if you ask them, which is what we prove here. And using other architectures on top of LLM like RAG or GraphRAG can significantly improve their prediction performance. And actually, this type of solution can be applied to other structured datasets. I want to acknowledge everyone in the AI for Life Sciences side group. The co-leaders are Akshin Behesti and also Kai Pham, and also all the very valuable team members, Shad, Pinar, and Risa, that have contributed to this research. So thank you so much.
Some of the challenges that you experienced as you were, for example, trying to get the LLM to just answer yes or no. So maybe you could share a little bit about some of those challenges that you experienced in designing these systems and where some of the loose ends still might be.
I don't know actually if Shad wants to collaborate in the answer, because I think Shad is the one that helped to fix a lot of the issues here. So Shad, are you there?
I'm putting you on the spot here, Diego.
Yeah, no, it's all right. I can answer. I just wanted another team member also to contribute. So we found several issues. First of all, it was on the embedding, on the type of embedding you need to use. So let's start here. So when talking about RAG, the first issue was the data format that you use. This took us a while to realize actually, because let's say if you put your data just as having a single drug and then you list all the side effects that are being caused by that drug, that is actually not good for an LLM, because the LLMs are, because they were trained on English vocabulary, on English text, basically they are learned to recognize the English sentence structure, which we didn't have in one of the formats that we used initially. So after we realized that the LLM was not interpreting that correctly, basically we changed the data format. So we played a lot with the data format, and that's actually how we came out with the second data format. That was the first challenge. And you can see that immediately here, right? You can see with one of the data format, we have around 88% inaccuracy, but when you change the data format, this is just changing the input. It's not changing the architecture, right? So here you have a massive improvement, an almost perfect system in all the binary classification metrics. The second challenge was that choosing the embedding size, all these like hyperparameters of the system that really improve the prediction performance. Also, Shad helped a lot here in the implementation to make this like a software engineering solution. He used these vector databases, which makes it much nicer and usable for other applications in case we want to scale this. And then another thing we also learned is that, for instance, we added this entity recognition here, which I didn't explain in detail. If basically, if you use this entity recognition for redesigning the prompt, this can also improve a lot the prediction performance. So yeah, basically the vector database is not perfect. So what's gonna happen is, let's say you are asking if whether aspirin can give you, I don't know, heart attack, just to say some very bad side effect, right? What can happen is that here you might get a lot of the terms that are related to aspirin, but not really heart attack, like very different, or maybe related side effect, but not exactly heart attack. So in order not to confuse the LLM with those very related side effect medical terms, basically we extract the drug side effect information from the prompt, and we use that to filter these results, the top result from the vector database. So if you use that, you can actually improve massively the prediction performance. This is something also we realized while doing this research. And once we learned all of this for RAG, it was very straightforward to translate the same findings for GraphRAG, which is actually a cleaner implementation, I would say, because here you actually go into the database and look if there is a link. So here there is no chance of making a mistake. So you either find the link or you don't find the link. Whereas here you are embedding a bunch of text, and then you query from that. Sorry for the long answer. But is there another question, maybe?
Yeah, can
this
you
is
repeat your last
Chad.
comment there? Can you repeat your last comment there, just about the text embeddings on that last slide that you presented? You cut out there just for a moment in the audience.
Yeah.
Yeah, can you repeat that part about the challenge here that you were just concluding on?
No, I was saying that for RAG, here the challenge is that because you embed chunk of text as just some vector in some space, it is much more imprecise when you query. Is not as precise as GraphRAG, because in GraphRAG you are already trying to find the specific link that you are looking for.
Fascinating, and thank you so much, Dr. Galeano. We really appreciate you coming in live from Paraguay today. Let's give it up for Dr. Galeano. Wonderful.
Thank you, everyone.
Our next speaker is Daryl Serrant. Daryl is a research scientist at Quai and a seasoned professional in software engineering and data science. He has over 12 years of experience in software development, analytics, and now AI. He has contributed to high-impact projects for startups and large tech organizations, and he currently shares his expertise by authoring courses on Gen AI and data analytics. Please join me in welcoming Daryl Serrant and his talk about making AI faster with state space models, an SSM. Get his slides up here, just a sec. Oh. Come on. AZ's got good advice. All right, wonderful, wonderful. You should be, you'll be recording through the Zoom here, and I've got your I don't know how this happened here. Yeah, grab a microphone here. Yeah, grab one of those, please. By the end of this, we'll have all these transitions sorted out and every combination and permutation thereof. You good?
Testing.
All right, that sounds great. He's going to Zoom over here. Yep.
Testing, testing. Awesome. Good afternoon, everybody. AI-powered language models like ChatGPT, Grok, and Claude have become incredibly powerful tools. Oh. All right. Revolutionizing everything. Okay. Revolutionizing everything from creative writing to business automation. But beneath the surface, these models face a fundamental challenge. And that challenge is efficiency. And today, I'm going to talk about how we can make AI models faster using state-space models as an alternative to transformers. And we'll talk to a couple things. We'll talk about transformers and why they are computationally expensive, and how state-space models provide an alternative method to process language. And we'll talk about my research on extracting finite state machines to make AI more interpretable and lightweight. And by the end of this talk, I hope to show you why state-space models matter and can be proved to be an alternative. No, there will be a exciting approach to better, more efficient machine learning. So, click. Hold on. All right, cool. So let's take a step back and talk about how we process language. Whether we are speaking, writing, reading, or listening, our brains are constantly shifting between different mental states. And we interpret meaning, we understand language, we try to anticipate what comes next in a sentence based on the context. And this happens quite naturally for us humans, but for AI models, capturing these shifting patterns is quite a challenge. Traditionally, finite state machines have been used to capture structure and structured language patterns. And what a finite state machine is, awesome. So what a finite state machine is, it's a system that contains a, oh, wow, back, okay. What a finite state machine is a system that contains a fixed number of states with rules that determine how we move between these states based on input. And an example of a finite state machine is a subway turnstile. So subway turnstile has two states, locked and unlocked. You insert a coin into the turnstile, it unlocks, and you push the bar on the turnstile, it locks again. So we can think of language in the same way. Certain words or phrases change our state of our understanding as we process them. But human language is far more complex, far more flexible, and far more context dependent than a turnstile. So there's a $1 million question. And a $1 million question is, how do we build models to capture this deep richness in human language while keeping things structured? So let me tell you about how things are being taken care of right now. So most AI language models today are built using a neural network architecture called the transformer. And transformers are incredibly powerful because they use an attention mechanism to compare every word in the input text to every other word. And that gives us deep contextual understanding, but it comes at a cost. For one thing, transformers don't have an explicit state representation. And what I mean by that is they do have internal states, but those states aren't represented as discrete transitions in the same way that an FSM does it. When they process text, they process all the text in parallel, which isn't the same way that, so it doesn't track structured state transitions the same way that an FSM will do it. And also, when they process text, they constantly recalculate the relationships between each word in an input sequence, which makes things not only very complicated to interpret, but also computationally expensive, computationally inefficient. So let me talk about state-space models. Wait, let me take a step back. I just forgot one more thing. So one more thing I want to mention about this. So if we were to try to extract an FSM from a transformer, we'll have a very difficult time with it because it stores its information isn't stores information in a way that actually lines up the way FSM stores information. Its information is, its knowledge in the transformer is distributed across different layers of the neural network. So let me talk about state space models. So state space models isn't something that's new. It's been used for decades in fields like engineering, finance, and economics to describe how systems evolve over time. And at the core, a finite state machine uses a series of equations to track the dynamics of a system and predict how new inputs in a system will react, what outputs it'll produce in response to inputs. So in recent years, state space models have been embedded within deep neural networks to create new type of AI models that work differently from transformers. And one of those models happens to be one that was developed in 2023 called Mamba. Mamba provides 3 key properties that make it give it an advantage over transformers. And the first property is, recurrent inferencing. Okay, there was supposed to be a little animation there, but it's fine. Okay, so recurrent inferencing. So that means, what I mean by that is Mamba processes input. So unlike transformers, where it basically takes all the input tokens and processes them all at the same time, Mamba processes its inputs one step at a time. And it's really similar to how we as humans read by absorbing words sequentially. So this allows Mamba to basically update its state as new information comes in. This makes it much more faster than transformers. So the second property is has to do with how it actually processes memory. So unlike transformers, which basically stores all its input sequences and basically attends to each word individually, Mamba actually compresses the entire history into a structured state matrix. And this is basically like how we, it's like, another way to think about it is how we take notes while we're reading a book, where we capture the most important things in a text without recording everything down. And that allows Mamba to capture a global state, a global context of its entire history without consuming excessive memory. And the third property is selective retention of data. So one of the challenges with traditional state space models is that they treat every piece of input equally. And this is actually how human reasoning works. So in language modeling tasks, certain words or phrases matter more important than others. So for example, if someone were to ask you what is the capital of France, the word France actually is more important than the words the or of. So to fix this, Mamba actually selectively picks which parts of it inputs it remembers. So why it does that is that it filters out some of the less important details over time, as it processes the input while boosting its memory of other information. And this gives it the capability of context. It gives it the ability to actually be context processing. So it allows it to do things like copy, select pieces of information from a text, or even learn from a few examples, similar to the way a transformer works. So let's take a look at how Mamba compares to transformers in terms of speed and accuracy. So I performed a series of benchmarks of Mamba and other transformers of similar sizes and complexity. I ran it against several benchmarks that measure common sense reasoning, inference, and text comprehension capabilities. And I found that Mamba performs just as well or better than transformers on these tasks. And that's primarily due to its structured state representation, which not only helps reduce overfitting, but also allows it to represent certain patterns in the data long-range dependencies in the input more precisely and compactly than the attention mechanism in transformers. So I also ran several speed tests on the same models, and I found that while transformers how I want to say it, while transformers scale quadratically, exponentially as the input lengths grow, Mamba speed actually scales linearly. And this has a number of practical benefits. One of them is the ability to, for companies that are trying to scale, deploy models, AI models at scale, this speed efficiency allows them to save a lot on cloud or hardware costs. The other benefit would be enabling companies to deploy their AI models on lower commodity hardware, unlike transformers that typically requires more higher end GPUs to run. And then the third benefit is for tasks that require processing long documents or analyzing large amounts of data, you can actually do this more efficiently without having to worry about excessive memory consumption or high latency. So why am I talking about this? What's the point in all this? So since Mamba can efficiently process information in a structured way, and while keeping a compressed, a structured state representation, this makes it a really good candidate for finite state machine extraction. So my ongoing research at Quai is to develop methods to extract finite state machines from Mamba to approximate its performance on certain modeling tasks. And this gives us a couple of things. So my goals are to acquire 3 things. So my first goal is to develop some tools that allow us to actually get some sort of more interpretability into how Mamba and other language models similar to it work. Because right now the state of AI is like we have a big black box, we have no idea how it works, how anything works. So this will, by having a finite state machine, we'll be able to actually study the insides of these language models and see how they work. And the other benefit is when it also gives us a layer of verifiability. So we can actually see if a language model, Mamba, is actually working the way we want it to. And this would be really important in applications that safety critical applications where like healthcare or any high stakes environment where making it like verifiability is really important. We don't want things to blow up in our face or people to die by using these AI models. And then the third thing is efficiency. So if we can get a model that closely approximates Mamba's behavior, we can actually replace it. We actually replace Mamba and in those applications where we can get even more efficiency out of it. So to take things off, we talked about transformers and why, despite being very powerful, they're computationally inefficient. We talked about state space models and Mamba and how they provide a more alternative way to process information while keeping things very efficient. We talked about some benchmarks, some experimental results that showed that Mamba is faster than transformers in certain tasks. And we talked a little bit about my research on extracting finite state machines to understand how to improve these models further. So Mamba is an exciting, to me, represents a really exciting path towards making AI more scalable and efficient, and an exciting way to make AI that is faster and accessible to not just big tech, but everyone as well. And if you'd like to contact me or get involved in the research, feel free to grab my information, and we'll see what we can do. You can all help with the research, so any help you can provide would be great. And I'm also available later during the networking reception later this evening if you want to talk there. Thank you.
That was fantastic. Thank you so much, Daryl. Well done. Yep. We're gonna mic up Balaji here while I introduce him, and try to get his slides up here in a quick and efficient fashion. Look at this. We're getting better now. Almost better. I've almost got it all down. It is a pleasure to introduce Balaji Lakshmanan. Balaji is the co-founder and chief technology officer at StudioBit.io. He has over 20 years of experience in advancing cloud conferencing and live streaming technologies. He holds 4 patents for his innovation in cloud switch architectures and ultra-low latency AV systems. We could use one of those here today. Yeah, mute this me. We got it. No.
I'm just going to mute that.
I need to open the page too.
So that one.
All right. Almost had it. Almost had it. As an advisor to Quai, he developed our very first RAG bot, Lumi, last year. And that was the first retrieval augmented generation assisted agent for answering questions about Quai itself. You can actually play with that on our website. Showcasing his deep expertise in AI integration and automation. Balaji's work focuses on AI-infused workflows that increase enterprise efficiency and drive innovation. It's a pleasure to introduce Balaji and his talk on the technical learnings of building a distributed and decentralized AI.
Thanks, Matt. Thanks, Riza.
You're just there.
Thanks, Matt, and thanks, Riza, for having me here. This is my second year. I joined Quai fall of 23, and it's been an exciting ride. Give me a moment to set up this web page, and we'll start.
Live demos. I'm excited. Check 1, 2.
Thanks. Again, excited to be here, talk about building distributed and decentralized AI. Last year was an exciting experience to bring the RAG bots, it was called then. Now, marketing department wants to call it agents, right? Bot is not cool, it's agents now. It'll continue to evolve. But at the pace at which things are changing, I think at Quai we have this 2 years of worth of discussions which has to materialize in some way or shape, and there's a lot of good thoughts that float around in the work groups, and I myself go through these thoughts and try to stitch these puzzle pieces, and I'm excited to say that this year we are able to distill some of those thoughts and materialize it in the form of a QuaiNet and see how we can transfer the value to the community. So with that being said, we are introducing a test network, QuaiNet. It is starting at the humble beginnings where the framework is borrowed from the Petals framework. Thanks to Brian Ragazzi, if he's here. Hey, Brian, are you here? Hey, Brian. Come on up here. Come on up here. I would like to, yeah, I wasn't sure whether Brian would be able to travel today, but so thanks to him, he introduced us to this Petals network, and we are able to visualize some of what we were talking about in actionable items. So let's see what's the motivation here. The motivation we started with Lumi version 1, which is a local RAG bot that was at that time, was that it is expensive to run it or host it in the cloud or even locally for someone with a gaming computer. You need deeper technological knowledge to do that. Higher cost. The cost here essentially is not just of a monetary value. We soon realize, if you've been through all day of this symposium, that it's more than cost. It's your privacy, it's your data sovereignty, and how you, what's your agency, and all these questions sum it up into one higher cost. Personal AI, right? That's another motivation for Quai, right? You have heard many talks about personalized AI and personal AI, and what's the distinction between these. Self-sustainability for Quai, it's very paramount that the community sustains itself. and able to provide resources for the community to research and develop and augment the vision of Quai. Data contracts, in one form or another, being talked about. Doc Searles talks about this in his IEEE. So we know that data occurs in layers, right? It starts with you, your personal data, then it becomes your family data, then your community data, and then your wider world. So data disseminates in different tiers, and how do we go about getting from a me to be economy or me to you economy in a very responsible and protected fashion? And that's the core of all this effort. So distribution of AI workload. We see the hardware manufacturers like NVIDIA have NVLink, which goes inside the data center for very low latency, offloading some of this to distributed units. We have other AI chipset manufacturers exploring PCIe or other forms of hardware technologies to distribute. What do we have? We have the internet, right? We have the TCP/IP, yes. It is decentralized, yes, the internet runs on it, but it has its varying network properties. So the challenge here is can we really get a distributed inference and training going? And that's what the core, the light bulb moment went on when Petals has already done it. They actually had a TechCrunch article in December 2022, which kind of probably got buried after ChatGPT got released. And when Brian introduced it to us, the Petals project itself was a little quiet, but we kind of with group effort, revived the whole project back into another form that I'm going to demonstrate. So what's the formula? So essentially, we have the Petals, HiveMind, DHT, and libp2p, which you have heard about in the cryptography talk track. Develop an OpenAI compliant API layer to the Petal nodes. So that's the piece that came together eventually. It was over time, people, again, there's multiple standards in this API business, right? And OpenAI RESTful API became popular. So it's now becoming lucrative to plug the system using that standardized method because there are many tools like OpenWebUI that can consume that type of API. So package the workload into Docker. Connect the API to OpenWebUI, and thanks in part to Zach and crew who brought in the OpenWebUI version of Lumi that encouraged us to, let's plug that in and make this demo possible. And most importantly, give the ability for people to deploy their own private community network. So again, it's beginning of the framework. Not all of it is done, like I said. It's not, we're promising everything, but it's starting at the ground floor, trying to build all the components that we talk about inside Quai, one by one, layer by layer, like Doc says. Nobody's going to build it, we have to. So what does the architecture look like? So Brian, would you like to talk about the whole Petals architecture?
Hello? Okay. Yeah, so the Quinite architecture uses well, it's a distributed model. Although this is not the original graphic that I had, so trying to speak to it will be a little bit different. What happens, though, basically is a new node connects to the network, and they hit a bootstrap node. So that has an actual well-known address. Can you hear me better now? Okay. Wow. Okay. So. Hello? Okay. All right. Wow, that's almost too loud. Okay, so a node joining the network will, let me get farther away, there we go. A node joining the network will hit a bootstrap node. So the cluster has a set of bootstrap nodes that have published addresses. A new node will connect to that, and that will connect it to the distributed hash table, which is not listed here, but that's the center of the whole thing. That's the common state and communication between nodes in the cluster. So then it uses libp2p, so if you don't have a globally addressable IP address, if you're behind a NAT or something like that, then it will create a gateway so that the other nodes can communicate with your nodes. You don't have to be on a cloud provider with a public IP or anything like that. You can run this out of your house and participate. I don't know if is this the whole thing, or is there further?
That's good, Brian.
Okay.
I think, so I'll explain this particular part where this is how, again, not all the pieces of the petals are listed, but just wanted to show how we have grouped in the QuiNet. There's an API layer for each distributed model, and then below which there are nodes here, which operate responding to that particular API layer. So we'll do a short demo to see how this all works. So this is, again, a small group of individuals participating in the QuiNet. We wanted to intentionally distribute it coast to coast, East Coast and West Coast. If you look at the table, there is Suleiman Sadori who has contributed. Again, we requested people to list voluntarily. It's not gathered from the machine, but they tagged it. So you can see a Xeon E3, there's a GTX 1080. So some of these graphics cards are probably 10 years old, like I have a 1060. So you can see there's a wide array of devices here. Some of the locations which are relay items these are not accurate because they are not being transmitted, the IPs. But again, the logic I have is probably a little buggy trying to pin everything to Las Vegas for some reason. Palos Verdes is definitely mine because I shared a direct IP address, so as you can see. So the distinction between direct and relay are the ones that are behind the NAT and firewall versus people who want to actually contribute towards direct addressability, and there's a reason for that. Right. Yeah. The direct node and the relay node. What's the reason why you want a direct node?
Yeah. Thank you. Beautiful.
Okay. Got it. Okay. So the topology part, I tried to come up with this diagram just to group in a short period of time. But you can see there are 2 bootstrap servers for this demo. There's a couple of API server nodes for each model, and there is individual different shaped objects because they come in different sizes, nodes below it, and these are all active and real right now. So what we have done is expose this via OpenAI compliant RESTful API, plugged it into OpenWeb UI, and created 3 different models, as you can see here, to run the RAG agent, not a bot. So the local Lumi, we call it, which is running within the Docker container using a Llama instruct locally. The QuiNet 3 billion is hosted by a few nodes here. As you can see, if I sort by the model, you can see there's 3 billion models and 8 billion models. It's set up in such a way that no single node owns all the blocks. The Llama 3 billion has 28 decoder blocks, and you can see it's split between multiple nodes. The similar case exists with the 8 billion, where no single node is owning all the blocks. And this is critical for this demo because it has to be proven that it will work in a distributed way. So with that said, we have 3 side-by-side, thanks to OpenWeb UI. There's a few underlying things with this particular demo is that it's already doing a few things more than last year. Essentially, when a query gets submitted, it goes through a task agent, which is a local Llama model that runs tasks like auto-completion or title generation or tags and stuff. But the main inference job gets to the QuiNet model. So we'll pick a random question here. Send it along. So obviously the local one should respond first. All of them will complete the knowledge request faster because it's local task, retrieving all those chunks, and now it's being submitted. Obviously, the local is faster. And the next two depends on the speed and how they are connected. And we can look at the table. Each of these nodes have different speeds and different latency measures. But still, nevertheless, they're coming back with a response, same as the local node, streaming from the community inference. And these are same instruct models, quantized slightly differently. We'll get into that. But as you can see, it's still coming back. Again, we have not done any performance improvements yet, like the OLAMA or other API endpoints where batching and caching and all kind of other fun stuff. It's just one token at a time being tokenized and passed through. So the response speed is probably in line with what I would expect without optimization. All right, let's go back to the quickly. I just quickly walked through a few things here. We did do benchmark with Grafana K6 for load testing and these Docker setup. And the primary driver we are going after is petals. Real world server, 32 tokens per second on a single batch size, or 179 for 64 batch size. That's the configuration they used. And with OLAMA local, which is again different protocol, different type of API server, I was getting about 100 odd tokens per second. With the QuiNet API, probably close to 2. With one node hosting all 32 blocks. This is east and west with 2 nodes, 16 blocks each. This is two node setup for 3 billion. So lessons learned, again, much of this is developer, but most critical thing is probably we have to tackle the quantization problem native to the graphics card to push the boundaries and batching. Those are the 2 things probably that will follow up. In a high level, where do we go from here? There are a few tasks as we have listed here that we will continue to pursue. And Brian is actively pursuing the distributed RAG architecture implementation, which is going to be next layer on top of what we are doing here. Brian, you have a few words about the distributed RAG architecture that you're working on?
We're out of time here. We are going to move into Q&A, however, for the research group. So thank you so much. Brian, don't go far. Balaji, don't go far. Take those good mics. And you're the keeper of the bad mic now, right? Keep that away from you. Daryl, come on back up, please. Have a seat. Riza, please go have a seat there. Maybe you have to share some mics here if we don't have all the good ones. I do want to give a proper introduction to Brian Ragazzi as well. So Brian Ragazzi, he's got a background in mathematics and computing and drives a lot of innovation across data management, AI, ML, security, and privacy. He's the distributed systems lead here at Quai. And he previously led cloud native and automation initiatives at major companies, including a medical technology infrastructure company with provable accuracy. We just saw some examples of that from Diego as well. He's a devoted champion of open source. He co-founded the San Fernando Valley Linux User Group. And he's fostered a thriving community of engineers and developers. He's also a SCaLE OG and has spoken here at SCaLE, back at SCaLE 5X. So we're super happy to have him back. I'll ask you all a few questions now and get some conversation going. Please, I'll go to each of you as I did the last time. These are for all of you, and Riza too, if he wants to join. He'll come later. He'll come. Let's start with you, Daryl. What's the importance of fundamental scientific research in AI advancement? We're all talking about big shiny toys, but more about the fundamentals. What are the importance of remembering the fundamentals?
Well, because fundamentals power everything. All the new and greatest and latest and greatest tools that are being put out there, they're all based on the fundamentals. So if you don't have a good understanding of how things work underneath the hood, then you can't really know how to push these models, these technologies further. So by spending a lot of time kind of understanding how these models work underneath the hood, the fundamentals, you can figure out how to actually make them go farther and stretch them against their limit. Yeah.
Balaji.
Fundamentals. Okay, so I'm not a research fellow, but fundamentals definitely form the well, very basis of what you do and how you function, how you, again, take for example, talking to the ChatGPT or anything, right? The questions you ask matter, in a way you ask matter, that comes from the foundation that you have laid and the fundamentals that you've learned. So I think that's how I approach the problem. Yeah.
Brian, thoughts?
The fundamentals are definitely important. This is a very complex field, and I think nobody understands every part of it entirely. There are a lot of subtleties to it, and there needs to be, to sort of spin the question a tiny bit. There needs to be more understanding of the fundamentals in the AI community, because, for example, there are a lot of people using LLMs just for everything, like doing clustering, which they're old school, machine learning techniques for. There are a lot of there's a rich history of machine learning and NLP, natural language processing, that has been going on for 40 years, and there's a lot of problems that are already solved, and people try to resolve them with LLMs, and there are certain things that LLMs are very good at, and so I think understanding the fundamentals helps you utilize the right tools for the right things.
Well said. Riza, and would you pass the mic there, Daryl? Thank you.
So look, we launched a research work stream at Quai right from the beginning, because we felt that fundamental AI research is so important to correct the three glaring problems of AI. One is we need to make AI smarter. And you heard from Dr. Galliano of how we're pushing the boundaries of GraphRAG and applications of it to make it smarter. The next was to make it faster. You heard from Daryl how we're breaking out from the quadratic nature of AI's scaling and exploring linear processes where you can scale AI in a linear fashion. So that makes it smarter, faster. And then the third big glaring problem in AI is it's got a disastrous carbon footprint. So we wanted to make it greener. And bringing AI down from the clouds of the oligopoly and to run at the edge is exactly what Balaji and Brian are doing in making models run distributed in a peer-to-peer fashion, in a collaborative format. And that is strength, that is power. So bringing AI down from the clouds, and there's no interest. The key vendors that control, maybe half a dozen vendors that control AI at the moment, have no interest in making AI run at the edge, because that would break down their moat, the moat that they have around that SaaS business where you're all paying $20 a month for. So what we're doing here is vitally important, Matt. We have to research fundamental AI because no one else is going to do it. It has to come from a non-profit, volunteer, open source movement. So I'm going to get off my hobby horse and, and hand it back to you.
Well said. Brian, I'd like to start with you here. How do you keep informed, and how do you suggest we all keep informed of advancements in this field? And, so we can also stay agile and taking advantage of them. How do you suggest we compose our systems to take best advantage of these different advancements?
Okay, so there are a few different things that I think you've asked there. First of all, how I keep abreast of it, well, one of the best things is joining an organization that's continually talking about it, like Quai. all the time there are conversations going on and people bringing in new technologies and techniques and that sort of thing. So that's a good place to start. All the social media feeds, you know, once you start reading into enough of it, it'll lock onto that and start throwing all kinds of stuff at you. So that's one place where the algorithm actually works in our favor. But how we can, you asked how we can build systems.
How do we take advantage of the advancements as they come? How do you suggest we design systems to take best advantage of advancements?
Well, this is going to be very familiar to people attending an open source conference, but having these be as open as possible, having any technology that comes out, if it's not open source, have open source equivalents of them built as soon as possible, and interoperability. Being able to take these different parts of the system and put them together, that's going to be really important.
Well said. Balaji.
Yeah, so when I think about, for the past 2 years or so, I've been following the trend. Technical or non-technical, I think one of the things I learned to avoid is the influencer marketing, because a lot of the stuff that floats in the social media are a glimpse into what it can do, but it's not all what it can do. Probably everybody has the unique experience. Either you don't have access to that technology, or there's something that happened in the lab and they put up video out of it. The best way I found is, because I've been in the startup business, I play with code, I play with technology, So if you're technical, please do play with technology. Don't refrain from it. Don't be afraid of touching it, because it's something new, and you probably, again, I'm not ashamed to say I know Fortran. I know COBOL. It doesn't matter. But at this point, people are latching onto the trend called vibe coding, right? Vibe coding is essentially ask something, copy paste into the thing, press debug, doesn't work, copy paste it back, loop, rinse and repeat. And you're learning as you're going through from the system, and you're feeding it real world data. And it's okay, because now we are upskilling ourselves and trying to match the speed at which technology is moving. That would be my recommendation for technical folks. For non-technical folks, please get involved in Quai. There's a lot of think tanks that we can learn and tune our thought process towards what's coming, and participate in the movement.
Well said. Daryl.
Awesome. So I'll echo probably first some of the things that Balaji and Brian said, but I'll also say that there's I constantly get hit with because I follow social media a lot. I have a couple of influencers that I follow closely on LinkedIn, which is where I'm more active. And then, even just popping on the feed, sometimes you see a lot of, news about different types of AI models that are hitting the market, and new tools and technology, and sometimes it could get even overwhelming for me. But what I like to do to kind of keep focus is just kind of pay attention to what are pay attention to what are the tools that I need to use kind of right now on a day-to-day job, or what I hear a lot of my friends and colleagues talk about, because chances are if I hear 5 or 10 people talking about the same thing, it tends to be this is probably the most relevant for me to focus on kind of as a professional. I can spend some time looking at some of the new tools, kind of get familiar with it, maybe read some couple of blog posts about it, read some YouTube, watch some YouTube videos, try to understand, get a sense of what the tools are, and then, if it's useful for my job, then I might spend some time kind of diving deep into it. So just kind of learning how to get kind of kind of a breadth of the tools that are out there, and kind of picking which ones to focus on the most is what I do, and kind of using some of my current responsibilities and what other people I hear talk about, kind of be as a guide to what I should probably spend the most time learning, because there's a lot of tools out there and it could be overwhelming. And just getting involved with organizations like Quai and other networks where they talk about these tools a lot is one of the great ways to keep abreast and take advantage of the opportunities that are out there. Yeah.
Matt, there's so much noise out there. It's not knowing what to listen to, it's knowing what to ignore. And so I've built a kind of filtration mechanism where I filter out the sort of mainstream noise, the cheerleaders of the status quo. I kind of filter those out. I start looking for the the fringe voices that are not heard much. And that's just an instinct that I've got for filtering my news feed and curating it. So there's little interest in the mainstream players to push the advance. And in fact, when there are radical advances that would improve the performance of the technology and show that it's actually not that hard, they all get upset about it. What happened when DeepSeek came on the market? They all got upset about it. The stock market had a complete hissy fit. That's not in our interests. What's in our interests is if it is easier, if it becomes more accessible so that we can wield AI ourselves, if they maintain this myth that it's really, really difficult and it can only run in our clouds with the moat around it and you have to keep paying for it, that is not a message that I want to perpetuate. And those people that do are just cheerleaders for the status quo. Off my soapbox, back to you.
No, well said. What to pay attention to, what not to pay attention to. Final question here. We'll get to the policy section next. What developing area of AI research has you most excited right now? Apart from the ones you just presented, of course. Balaji, why don't you kick us off?
Yeah, for me, I think based on the progress that we have made within Quai itself, I'm more interested in learning about the state space model, because the primary handicap of what we have demonstrated here is they're autoregressive. Essentially, every token has to be looped back 32 blocks again and again until the whole sentence forms. And the state space models parallelizes this process, and that would give tremendous speed boost. The second part I personally am going to focus is how to do distributed training. Now we got the inference taken care of. Now it's an optimization problem. How can we actually do training? And Petals has framework for that too. So essentially, we are entering the era of intense personalization, I feel, where model is going to become a product. Now, when that happens, you want to be able to train your own model the way you want to see fit. And when that happens, would you go to the cloud and train it? Would you train it in a community? Do you train it in your own PC? You should have freedom to do that.
Well said. How about you, Daryl?
Let's see. So aside from my current research on state space models, one research area that I've been particularly interested in is multi-agent systems, just kind of understanding how you build these agents that can actually work together and actually do some really cool, interesting things. Agents have been a lot in the media a lot lately, and I just think it'd be a cool area to kind of take a look at, and how do you actually, and on top of that, how do we actually build agents of, because one of the limitations of agents is like the memory, like after a certain period of time, the agents can only remember so much information, and after a particular time, it just starts hallucinating and just doing crazy things. So we'd really love to spend some time kind of investigating memory, like how can we actually improve the memory of these AI systems so we can actually do a lot more and retain a lot more of the information and propose some more cool stuff out of it. Yeah.
Brian, how about you?
Well, okay. Besides what we're working on, okay, because I came in the door at Quai already really excited about distributed training and inference and all of that. I would say probably at this point, sort of twofold, the agentic type work, but plugging it into things that we already use a lot, say in the Linux world, plugging it into real functions of your operating system. Not, okay, now it can do some browsing for you. That's also good. That's also very important. But there are a lot of functions that we deal with every day using computers that people aren't paying as much attention to. And I think the agentic model could work really well with that and really revolutionize how we use computers. And that kind of ties into the second thing, which is that 20, 25, 30 years ago, there was this little operating system no one had heard of called Linux, and there were big companies that did not want to see Linux succeed. And the open source movement fought that back, and now Linux is very well regarded. Some people would say it's dominant. Most of the operating systems installed are actually Linux. We're at the same point with AI. We're at a place where it's kind of niche, at least the real work in it. Lots of people are playing with the stuff by OpenAI, but that's kind of like Microsoft 20, 30 years ago. And people think that they have to be dependent on that rather than liberating people and being able to use this technology themselves. So I think I'm excited to see the open source fight over the next 20 years like we've seen over the last 20 years for Linux.
Well said. Reza, last word briefly.
Yeah, briefly. So the thing that excites me is an opportunity to look at AI differently. And I spoke about this last year. We've kind of treating AI like the only hammer in our tool belt. And so every problem, if the only tool you have in your tool belt is a hammer, every problem looks like a nail. And so we're using AI, we're using probabilistic models as the way of solving all of our problems. Well, it turns out that not everything is probabilistic. Some of them are purely deterministic, but there's also a mixture of the two. What's exciting me about what Daryl's working on is the possibility of taking a probabilistic model, which is most of our language models, and being able to extract from it a deterministic model and a smaller probabilistic model. So what would that look like? For language, the deterministic model would be the grammars and the syntax of the language. Well, we know what those are, but these could maybe be extracted from the LLM, and then the remaining model would be a whole lot smaller, and hey, more computable, hey, more accessible for all of us, not just something where your words go up to a cloud and have to come back. So that I think is gonna emerge, where we start seeing AI as a bit more nuanced and not just a completely, what did I call it last year? I said it was the height of intellectual laziness, where you look at a problem and say, well, I don't know what the physics is behind it, but I'm going to just throw in all the historical data and try and predict what's next, what's the next word or whatever. We're still at the foothills of that type of exploration, but come to Quai, and we're having that conversation, and we're doing real cutting-edge research. We don't want to pre-announce stuff, because that just wrecks our credibility. But when we've got stuff to demo, as Brian and Balaji showed today, we all demo it. Come and join the movement.
Well said. Well, thank you to our panel. Appreciate you. Yeah, please turn those mics off. Thank you. We are going to move into the final section, home stretch, and get that to Reza there. The next person I'd like to invite up is Steve Vitka. Steve, where are you at? There you are, Steve. Wonderful. So Steve is a pioneer of one of the world's first co-working spaces back in the 90s, before co-working was cool. From organizing raves and unconferences to championing alternative economies and direct action, Steve has consistently pushed the boundaries of collaborative innovation and social activism. Today, Steve explores personally owned digital twins as a possible post-hierarchy solution, drawing on decades of community building experience to envision a more equitable digital future. Please join me in welcoming Steve Vitka and his ethical learnings for building a distributed and decentralized AI. We'll get you wired up here. Twin side. Oh, that's your old one. Hold on. Get you your new one.
I don't know if you might want to give me the regular microphone. I'm pretty naturally loud. You can all hear me, right? Yeah, across Zoom they can, but I don't want to be too loud on my levels up too.
All right, here we go.
Putting this, put one in my pocket. Oh. Okay.
There's your advance.
All right, I'll put my timer down here.
And so the next few speakers will really be talking about this from a policy perspective. You just heard smarter, faster, greener Now let's talk a little bit about SAFER and some of the perspectives on that.
And what do we even pay attention to there? There's so many issues.
Thank you. Appreciate you, Steve, and thanks for that.
Including my intro, this still was only 13 minutes.
Yeah, you had 12.
I thought I had 15. All right.
Wonderful, but thank you so much. Our next speaker, look, Steve, I love you, man, but our next speaker is absolutely my favorite speaker. I love hearing him speak. I love talking about him. It's me. I'm gonna get mic'd up here as I get the show going. My background, I've been in the cloud game for over 15 years now. Worked at a bunch of transformational companies like SCaLE, Bitnami, an open source arms dealer to the cloud providers. You probably used a Bitnami image if you ever ran WordPress. I currently work for Flexera, and I give them a big shout out because they have a motto called "Give Back," and we should all be giving back to our community. And they supported my attendance here. They took care of my travel and sending me down here. So huge shout out to Flexera. We provide FinOps capabilities for managing your cloud spend. We're also looking at how that applies to AI and how AI applies to FinOps. So my talk today is really about open source policy and its importance to everything that we've talked about here. And I'm presenting this, but really I got to give a huge shout out to Sam Johnston, Quai board member in absentia. He wasn't able to join us today due to an unforeseen circumstance, and I'm going to do my best to represent him. I also thank him for a lot of the content and slides that I'm going to be presenting here today. And his work that he's doing with the Open Source Alliance. So let's start with a definition of open source. Well, open is relatively well understood, freely available, accessible. Source has a bit of a different connotation. If I have a water bottle, I wish I had a prop here, but if I had a water bottle, I could open it, I could drink the water, but is that water the source? Is the object itself the source? No, the source is the spring that water came from. So when we think about open source, this is really the source of the innovation, the source of where the thing come from, the source of the salmon, the source of the water, the source of the code, or the source of the data. And many of you have seen XKCD. Wouldn't be a conference without seeing some XKCD. There is a $30 billion industry built on open source, growing to $80 billion. $8.8 trillion of economic activity is underpinned by open source. 97% of software runs with open source libraries. So, this is not, the first thing that we really want to do here as we're developing AI systems is to do no harm to open source. Open source is hugely important. It's hugely important for all of us to take a piece of it. It's really based on the 4 essential freedoms, and these are a bit simplified here, but the 4 essential freedoms, Free Software Foundation, to use the software, to be able to study the software, to modify it, and to be able to share it freely. Those are the 4 essential freedoms of the Free Software Foundation. Again, modified just a little bit for the sake of the formatting. The open source definition evolved to break these down and to kind of make it a little more tangible in real life. It talks about the free redistribution, the source code, the derived works, integrity of the author, the distribution of the license, and it broke these things down into 10 essential pieces of the definition. And this worked pretty well. The problem is with number 2 now, the source code. With AI systems, the definition of source code is evolving a bit. The code of an AI model is frankly just a little sliver on top of the weights of the data. Open source definition, a project from Sam Johnston, is trying to make sure that we all have a say into how this definition evolves, now that this definition is evolving, and I'll get to that. These, licenses exist. There are, I think, 98 licenses, maybe 90 too many. But, open source licenses really govern the distribution of those things. These are all licenses that are compliant with the open source definitions, one of many more that are found there. But to take a little history tour here, this really kind of all got to start with those 4 essential freedoms, the formation of the Free Software Foundation back in 1985. There's a long-haired Linux guy that was really pissed off that Xerox wouldn't let him get the notifications from the copy machine. And so he started building something out in the open. 1991, Linus released the Linux kernel. That really catalyzed a lot of the reason why we're all here today. 97, the Debian social contract. These are a bunch of folks that got together and said, Bruce Perrins, Eric Raymond got together and said, we like the free software ideas, but it needs to be a little more business friendly. Let's write some licenses for it. 98, the year later, these same folks got together and formed the Open Source Initiative and the first draft of the open source definition. It was actually Christine Peterson that coined the term open source, so shout out to Christine and her work, Netscape. There were 10 revisions of that up and through the years here. In 2007, cloud computing came out, and OSI was rather, they were not really participant in how cloud computing started to change the definition of this. So along came AGPL, again from the Free Software Foundation. 2017, artificial intelligence, the publication of Attention is All We Need. And then, ChatGPT a couple years later, really capitalizing on that. And that's where things really started to kind of come off the rails for the definition. And we have a current situation now with the release of the open source AI definition. And I'll talk a little bit about kind of where things are headed here. But back to history for a moment. We actually talked a lot about this back when Quake was released, because Quake came out and said, hey, Quake is open source. Well, the Quake engine was open source, but all the data that made up Quake, the textures, the monsters, the gameplay and all of that wasn't open source. So they started trying to, hey, Quake's open source. No, the Quake engine's open source. You can see all the forks that came of it since then. But it wasn't the game Quake. And there's a parallel here to that to today's AI models. Without the data, is it really the model? Is it really open source? I talked about the Affero GPL license a little bit. This created what's called the service provider loophole in 2007, which was basically service providers able to say, well, we don't have to convey the bits here. We can deliver it over the network as a service. And that's something that's really being capitalized now by those centralized AI services. Attention is all you need in 2007, and as Sam likes to say, super clippy in 2022, ChatGPT. This is where it really started coming off the rails. And even the Free Software Foundation, methodical and maybe a bit late to make a lot of noise in this area, but even they're starting to realize that, look, with these new AI models, the system is not just the source code. I don't say that my laptop is open source. It runs Mac OS, definitely not open source. That's built on open source, FreeBSD. I have open source software on it, like Homebrew, but the Mac itself, the computer, the system is not open source. But we have an issue now where there are definitions evolving that seem to state that, hey, you don't need all of the things that make software open and free to study, to distribute, and to create business on. So a little bit about this slide, just the openness versus completeness. Open source definition over there, 1.9, current version from the Open Source Initiative. Very open, but not very complete into how these things are operationalized. I'll talk a little bit more about that. Linux Foundation came out with a version, the Model Openness Framework, which has a big, long checklist of all the things, a very complete checklist, but they actually fail on the test of openness, and I'll talk a little bit more about that too. The open source AI definition is extremely controversial right now in that it's failing both in the test of openness and completeness. And so this is really where the challenge is. And the open source definition work in progress, which I'll end on, is an attempt to address that. So the Model Openness Framework from the Linux Foundation, very complete, lots of different classes. Two things here that I've highlighted. One is that it says, hey, we require the data set, but it says with any license or even unlicensed. So, Common Crawl, which is a dump of the internet, which includes all things that are unlicensed content, is acceptable here. So maybe it's not open. It also is actually requiring documentation, which has never been asked for before in a definition of open source, and it's not necessarily needed to add, frankly. You could have a quantum library that's code, that's uncommented code that 2 people in the world understand, but if you put it out there for people to study it, for people to look at it, for people to take it and use it and reproduce it, then it's open source. It's valid open source code. OSI and their open source AI definition, they said, okay, yeah, we love the 4 essential freedoms. Let's get some more resolution to it. We'll talk about open weights. They talk about open code, and they even say, hey, let's include the data here. That's important. But there's this big asterisk at the bottom when legally possible. So what's any lawyer at any corporation going to do is they're just going to X out that column. Not possible. Sorry, not going to give the data away. Bruce Perrins is catching on to this. Again, one of the original open source definition authors and original OSI founder. Hey, this is really open washing. This is calling things open source that are not actually open source and are moving away from some of the original freedoms. There have been a bunch of excuses for this. Open source AI doesn't exist. Well, now we have good examples like Olmo, freely open source data set. Personally identifiable information like medical records in there. We got to get consent from people. Tech industry doesn't do well with consent. Text and data mining exemption. Hey, we can take the data from this exemption, but that's actually only allowing the use for study, not reproduction. If you compress all of Mickey Mouse and it starts regurgitating Mickey Mouse, then that's not the same thing as studying Mickey Mouse. Now you're reproducing it. Security by obscurity. There's even the national security flag that's way, hey, we can't do open source because then this nation state or that nation state is going to run away with it. Hardware costs are an excuse. Even CSAM, child sexual abuse material, the most abhorrent material on the internet, that exists inside some of these models and has then been used by the model creator to say, oh, well, that's why we can't give you the data. Well, they can use it, but they can't give it to you. And even the EU AI Act has an exemption, and that exemption says, hey, AI models that are released under a free and open source license, they get some exemptions with regards to their transparency-related requirements, which that's now enshrined in the EU AI Act. Ben Brooks does not agree. He says that Berkman Klein Center, Harvard University there, along with Bruce, Schneier, OSAID serves a noble but altogether different purposes. It is not describing open source software. What the open source AI definition is, essentially, it's not a very particularly good example, but it's an example of an open weight definition, which, hey, the model weights are included. And the general argument is like, great, if there's a definition for this, then just call it that, don't call it open source. Because now we're conflating things that already have a general understanding in the world, the whole reason that we're here at SCaLE. And so the open source definition is a project, opensourcedefinition.org, where we've taken all the versions of the open source definition, and now we've got that little work in progress definition at the top. So 1.9 is the current, but what does 2.0 actually look like? So I talked a little bit about this. Open code, really just a sliver of the AI pyramid. Open weights gives you a little more insight into how the things work. DeepSeek, another good example of an open weights model. But open data is really the corpus that makes the whole thing work. The weights kind of give some instructions, and then the code basically just animates the data. But in order to truly study an AI model, you need access to the data. So open source 2.0, this is a working group. Please get involved, opensourcedefinition.org, where we're hacking on the open source 2.0 definition and how we might take this forward with something that, enshrines potentially things like the 4 freedoms. There's plenty of other suggestions that are being contributed here openly and transparently. And why is this important to Kwai? Well, Kwai has a bias that we just heard that education was a key, key component to all of this, user education. People should know what they're putting in their personal AI pipelines, whether it's a service that's siphoning their data or whether it's a model with particular bias. And if people don't have the ability to study those things that they're putting into their pipelines, then we can't truly have the transparency as to how we are being influenced. Because yes, the service providers have their influence. Models themselves have bias and influence based on the training data included. So we are huge proponents, again, and just to conclude here on the 4 freedoms, that software should be usable, yes. It should be studyable all the way down to the individual component pieces that make it up. It should be modifiable. You should know what pieces that you need to change if, for example, we wanted to take that CSAM out of there. And it should be shareable. So that concludes this little piece here. Thank you for all of this. Thank you to Sam Johnston for his inspiration and help putting all the slides together. Really appreciate all your time. Yeah, Richard's up next here. All right, I think I'm now a minute over too. Richard, come on up here. Here, I'll let you get him up here. Let me get back to my stuff. All right, so Richard's our closer. You're going to hear from Riza one more time, get you all a nice rah-rah call to action. But Richard, pleasure to introduce him. Richard is a public policy attorney, a technology strategist, and an entrepreneur with over 3 decades shaping telecom, internet, and AI policy. He spent 11 years at Google, 4 as corporate director of strategic initiatives, spearheading work in digital governance and open internet policy, and then served as a vice president for government relations at Twilio, and as a senior fellow at the Mozilla Foundation. In 2018, he founded GLIA Foundation, sponsor of the Kwai Symposium, thank you, Richard and GLIA, and launched GLIANet to advance net fiduciaries and personal AI agents. As detailed in his book, Reweaving the Web, come see him at the booth for a signed copy. Richard earned his Juris Doctor from Georgetown University Law and a bachelor's from James Madison University. He remains a senior fellow at Georgetown Institute of Technology Law and Policy. Please join me in welcoming Richard Witt for his talk, Governing AI for Autonomous Humans. I got it, Riza.
Thank you, Matt. Thanks, folks. You okay? Great to be back at the summit this year.
Oh, sorry, I didn't give you one. Details. That's for different things.
Ah, okay.
There you go.
Okay, cool. I'll do my radio voice. Anyway, I know I'm standing between you all and Twilight, our reception after the event this afternoon, so I'll go through this fairly quickly. Thank you for that introduction. Pleased to be a co-sponsor here of the summit this year with my GLIANet Alliance, and I'll talk about what that means and why we need a governance layer on top of all the amazing technology that we've been talking about earlier this afternoon. So Matt briefly mentioned a book. I did in fact write a book last fall based in part on my 12 years of experience at Google, defending the company, as it turns out, mostly incorrectly from those who are asserting that it was violating privacy and basic human agency and autonomy in the world. So Reweaving the Web, it's actually going to be tomorrow. We have the booth, what is it, 112? over in the SCaLE 22. I'll be signing books and selling them, but all the proceeds will go to Kwai, so 100%. So if you want to give some money to Kwai, come by, get a book, give money to a wonderful cause. So what's this GliaNet thing? So I talk about it in the book a little bit. I focus a bit on the challenges of the web, but one of my assertions is that we spend way too much time talking about the problems and not having specific solutions. And as a lawyer, that really bugs the hell out of me. So, this is what I come up with is sort of the overarching thematic of what's wrong with the web in the last 20 years. I call it the SEAMS paradigm, surveillance, extraction, analysis, manipulation. Nothing really new here. It's based on Shoshana Zuboff and lots of other amazing folks who have done this analysis. I've actually talked to the people at the companies doing all of this, and it's all very clear. Even the term manipulation, which I first came up with 7, 8 years ago, some people thought that was a tad strong. Now I think it's actually right on point, if not even in the age of AI, underselling it a bit. So glia is the ancient Greek word for glue. And I chose it for my project for a couple of reasons. One is, and we've talked about it a number of times here this afternoon, and it's the word that keeps coming up over and over again, it's trust. And in fact, this notion that we have a lack of trust in society between individuals and companies, our political systems, all of that, right? Our communities of interest. And trust is the social glue that does in fact hold us together. The web did not create that problem, but it has certainly exacerbated it. And so one of the things I'm hoping to do with my project is build authentic human trust into the way that we govern advanced technology systems, including, of course, AI. There's also this notion of accountability. In Spider-Man, Uncle Ben tells the young Peter Parker, right before Uncle Ben gets offed, that with great power comes great responsibility. Those who have the power, of course, don't want the responsibility, so in that case, the glue has come asunder. We need to sort of build that accountability back into the system somehow. And then finally, the glial cells in the brain. A really interesting story. Those cells actually, in the late 19th century, when they first did the scans of the cranium, they could see all the neurons because their electrical signals are going very rapidly. And then they saw the stuff in between that looked like it was inert. And they said, well, this isn't doing anything. It must be gluing the neurons together, so we'll use the term glial. As it turns out, glial cells work on chemicals, not on electrical signals, and therefore we're not showing up in the brain scans. And in fact, they do an amazing amount of things to promote, enhance, and protect the neural systems. So I like that notion of having sort of a human support system behind all of the things happening with the neural structures that we're building in the AI systems. I also like to say, since I'm from Silicon Valley, you go to a typical, happy hour, there's tons of neural networks everywhere. There's very few glials sort of standing around, holding a gin and tonic. So I think we need a bunch more of this going forward. So I basically have this notion of what I call a layered trust fabric. And this is just the multiple elements that make up sort of a typical sort of ecosystem approach. And again, as a lawyer, governance to me sort of go on the top. Governance is basically just the rules of the road, right? You could talk about laws and regulations and constitutional amendments at the very highest level. Those are like the strongest forms of governance in the public sector. And then you have the private sector, which tend to be things like terms of service, right? APIs are a good example of governance in a sense. We don't think about it that way often, but these are typically unilaterally published by a company. We then utilize it, and then if the company decides the next day they want to change it, they can, and they do. And so that is a form of governance. And then we, of course, we have markets, we have technology, and then we have the public policy side of it, which is how do you change the rules of the road, both in the public sector and perhaps for the private sector as well. Matt mentioned net fiduciary. This is the core, sort of the core ingredient that I came up with in my years of thinking about this, first at Google and then at the Mozilla Foundation. We have fiduciaries in our lives today, right? We have doctors, we have lawyers, financial advisors, even librarians have a certain fiduciary duty towards us. When we check out a book, they don't share those records with the government, right? And it's this idea that goes back to hundreds of years of the common law, but the underlying premise of this, and many scholars have talked about it and written about it, is the notion of a power asymmetry. So if somebody has an expertise that I lack, you're creating right there an imbalance between the two of us. If I have to share confidences with you in order for you to utilize your expertise to make my life better, that deepens or exacerbates that power asymmetry. And so we have these situations. We have, over the years as a society, in the medical profession, the legal profession, and elsewhere, decided there should be fiduciary duties that apply that come from the common law. And I'll go to the basics in a second. But the idea here is we had this in the 20th century, essentially, in the early 21st century, in the analog world around us. We have nothing like that on the web. And yet I would argue that the data that we are providing, surreptitiously or otherwise, to the platforms, now the AI agents that want to probe deeply into our psychology in order to understand us and do things for us, we in fact have a greater power asymmetry than at really any other point that I can think of, going back again through the hundreds of years of the history of these professions and the like. So my belief is we need to have a new sector, perhaps even a new profession, of entities and individuals who are net fiduciaries. So here's a framework that I came up with that tries to map this to the particular kind of role, and then an example that I think we could all hopefully understand and appreciate from the web. So the three basics here are protect, enhance, and promote. The lowest level, protect, is a basic duty of care, which in fact shows up in a number of statutes around the world for basic industries. So you do something to somebody. The basic notion is no harm. Whatever you're doing, don't harm me. Seems pretty low level, but it is a pretty important premise, right? If there are companies operating out there, and of course many are, who don't have that basic obligation, they can do whatever they want to, even if there's objectively harm that's being caused to you or your community. And so, as the web example there, it's pretty straightforward. Again, strengthening your personal data, putting up a moat around me if I want one, right? To protect my data, keep it safe, put it in a solid pod in my living room, so Tim Berners-Lee will be pleased that he finally figured out a way to try to rectify the errors of the web. That's sort of the lowest level. The middle level is an enhance function, and for that I call that a mediator. So somebody sort of acting to mediate for you on your behalf with the web, and the example I use there is news feeds. If I want to set up an algorithm that says these are the 20 news sources I find the most relevant to me, I should have the right to do that. And this entity would help me to do that in ways consistent with what I want. And then the highest level is promote. And that is the idea of an advocate of loyalty. The duty of loyalty is the strongest. That's to promote my best interests. That's what doctors and lawyers, by professional code and conduct, are bound to do for us, with few exceptions. And this comes back to intent casting. So we had Doc Searles on earlier. He's been a great supporter of this idea of intent casting myself into the web. A particular example is shopping. His wife Joyce has talked about the universal shopping cart. Why can't I take my cart to the websites, do my shopping perhaps in a synonymous manner in ways that fulfill my needs, but without sharing, spreading my data? My intentionality is all over the web. And so this is just one example, pairing the idea of a net fiduciary with an edge-based technology. The one we've been talking about, of course, this afternoon is the authentic personal AI agent, which then in turn interacts with what I call institutional AIs. So Doc calls them corporate AIs, I call them institutional, but it's the same notion. The ones over there on the right want us to believe, per Bruce Schneier, that they are our friends. And in fact, as Bruce very well lays out, they are double agents. They're not really acting on our behalf. And so if we have an agent that in fact abides by duties of care and loyalty to me under the auspices of a net fiduciary, then you are in fact, you have both the technology and the governance on your side to help try to right some of that power imbalance. How much longer? Okay. So this is a proposed theory of change, and I'll go through these slides very quickly because I could love to talk more about this at the panel, and then if you see me all tomorrow at the book signing. But the theory of change is within the next 6, 7, 8 years, there's no reason we can't have 50 million people in the United States who are served by a net fiduciary and 50 million people utilizing these kinds of agents. Some people say that sounds crazy. Some people say it sounds woefully underwhelming. But I think looking at it in terms of the different elements I laid out earlier, right? The private governance, designing the technology, public governance, and the social fabric, which is in some ways the most important, which is convincing the ordinary person that their expectations are way too low. And then in fact, the platform companies have done a wonderful job of telling us, you have no privacy, forget about it, give up, it's useless. And now the AIs are going to build on top of all of that when in fact it's the exact opposite. We're now opening up a huge world of opportunity and potential, and the average person needs to be excited about that. And so my GleanNet Alliance, so-called Coalition of the Willing, so far we have 20 companies in the mix. Very pleased to have Kwai there as one of the inaugural members, as well as Personal.ai Encrypted, who you heard from, some of you heard from this morning across the way. And it's attempting to look at each of these 4 different layers and building out what we call a community of practice. So understanding what is an ethical business model, right? What's a privacy policy where the first sentence says, it's your data, not mine, right? I mean, these are like different ways of putting governance into the world, as well as, again, the business models themselves and the technologies and all of that. We have a statement of principles, again, nothing too earth-shattering there, it's just acknowledging the current problems with the web and a desire of these different, mostly smaller startups to work together to explore becoming essentially net fiduciaries in the world. Our provisional roadmap, we're over there now on phase 3, which is working groups to look at each of those different components over time, moving towards phase 4, which is moving essentially from a community of practice to a community of practitioners, whether that means having a licensing, certification, trust marks, back-end enforcement regimes, all that to be decided. One quick thing I'll mention, and then we can move to the panel. The 2 dimensions of AI agency, and again, we've sort of talked about it a bit today, but I want to put a slightly finer point on it. Agency, or the notion of an agent, has 2 definitions, or 2 aspects of the definition. The one that OpenAI wants us to always focus on is the agenticity, the agenticness, and that's what we hear all the time, agenticity. That's about taking actions in the world, making decisions, doing advanced stuff on behalf of somebody, but the on behalf of somebody is the part that tends to get missed. And so I call that agentiality. It's another adverb. But the notion there is that it has to be something authorized by the actual human being. Somebody mentioned Clippy earlier, so this is one way to think about it. As we move into more agentic capabilities, from bots to assistants, all the way up to eventually autonomous agents, right, acting ostensibly for us, we need to also, on the relationship side, move from just being a mere user to having a duty of care, ultimately to duty of loyalty. So again, with more power, more responsibility. Poor Clippy there, of course, was just he was an annoyance more than anything else back in the 90s. But his brethren are going to be out there and already are out there very soon. This is ecosystem mapping of our membership. This is the leadership. And I thank you all. And if you're interested in joining the Alliance, please come talk to me. Thanks.
Thank you, Richard. Appreciate that. I'm going to ask you to stay up here. I'm going to ask you to keep holding on to this.
Okay.
You can get all your mics switched up.
All the stuff.
Our final panel of the night is our policy panel. Is Nick here? Nick Arzen?
So we're just coming down here?
Didn't think so. Yeah, come on down here. Ruth, welcome you back here. Steve, come on up, please. Reezy, you want to sit on this as well? You got one extra seat.
Oh, thank you.
Is Zach here? Hey, Zach, get up here. Get up here. Come on. All right. Quick substitution. Thanks. We're doing it live. So our final panel here, and I'm sorry, Zach, I don't have the picture right up here in front, but I can do that real quick. Zach Schenkler here is the current serving VP of Kwai, a corporate officer of the organization. He helps you keep the train on the tracks, as the saying goes. So thank you, Zach, for keeping this train on the tracks. Get to some of my questions for y'all.
Don't do that again.
So, AI policy, all right. It's going to be a bit of an open-ended one. Ruth, maybe I'll start with you over here. What does democratization of AI mean to you?
If you'd asked me that a year ago, I would have got a different answer, I think. But it's Kwai's attempt to give us what Richard was just talking about, agency, what was it? Agenticity and agentiality. I love when people manipulate language like that. I think it carries that responsibility as well, that we need to be aware of the way that we are using these tools, rather than being victims of these tools.
Thank you. Zach?
Check, check. All right. Well, democratization, I guess, can have a lot of meanings, right? Personal AI is personalization. But to me, democratization means access and participation. It means that no matter your technical skill set, no matter your knowledge, no matter your position, no matter your situation in life, you are able to access that information, that technology, that capability, and you're able to enhance yourself. That's, for me, that's what true democratization means.
Steve?
Ultimately, let me see if I can turn this on. I'll use yours, thanks. Yeah, I mean, ultimately, I see a society of digital twins with humans acting in concert with them and, participating in democracy directly, like I said, and having a much more direct democracy because we have these agents which can represent us not only in, government as we know it, but in any larger association. And everything else these guys are saying too on the way to getting there.
Yeah, I agree with all of that. And I think the other thing I would say, this crowd tends to focus on democratization as a technology parameter, something to build in at the outset, maybe to make it more edge-based.
You guys need to switch.
Oh, yeah. We tend to think about it as, from the technology viewpoint, right? Something that maybe is on the edge, gives me more control. And I guess as I would like to just say, put ourselves in demos is the many, that's the Greek term, right? The many people have no clue what open source means. They don't know how to keep their private and public keys. They don't even know what they are, right? And so if we really want to democratize the technology, we need to bring it down to their level. And that's where I believe that's where the governance comes in. That's where we have intermediaries that people can use. You don't need to use them, and some folks in this crowd would never, and that's totally fine. I totally understand the notion of disaggregation, moving away from intermediaries, but for many people, it's a source of support and a place to go to when things go wrong. So having that entity there, always there to work with people, to help them take the technology on board, and then get that full autonomy and agency out of it. I think that's a part of the process.
Well said. What would you say to those who see ethical considerations as a hindrance to progress? Zach, how about we start with you?
Ethical considerations as a hindrance to progress. I think that needs its own symposium.
Well, you're on the spot now.
Yeah, I know. That's why you chose me first. I go back to this word democratization and what it means to each individual. I think that there is a concept of an ethical standard, a concept of governance as a framework, a concept of guidelines, but I think ethicalness is also relative to each individual and how they walk through their own lives. Is it a barrier to technological progress? I think that once we pose or impose our own ethical influence on the progress of technology, it stops the conversation. And by stopping the conversation, we stop the research, and then we start focusing on elements that don't push the progress forward and mire us in cyclical black holes of non-progress. And that, to me, and look, ethical is important, but to me, it's got to come down to how you communicate that from person to person, right? And digital twins, right? If you imbue your ethical nature into that digital twin, and then we have a fiduciary framework of governance on top of it, then maybe we have a working model for relationships, for interrelatedness.
Well said. Steve.
Yeah, ethical progress is the only progress. All the others are illusionary. Most of the supposed economic growth of this country in the last 50 years is just new ways to financialize things or, leverage things that already exist without actually producing the things that make people happy. So, and you're certainly right. I mean, the thing is that we can't define ethics globally or we're going to get some sort of value lock-in, potentially. So, and in just a, societal inflexibility and, all the problems that we have with large-scale conflicts. So if we take that down to a granular level and really operationalize personal ethics so that you can have your twin go out in the world and, perform your ethics for you, then you can see those results and give it feedback and improve your personal contribution to the ethics sphere, or whatever we want to call it.
Yeah, one of the things I learned as a lawyer at Google is that the people who use our products and services are users. And when I would question that, I'm like, well, why don't we call them like customers or clients or patrons? No, that implies an obligation. And so I learned that being a user basically meant you had no rights except the rights given to you by the company. And hopefully even that was, the minimal necessary that a carefully crafting lawyer would put in the terms of service. So I think that low to basically non-existent ethical layer on the current web is what's frankly holding back the technology innovation, because now we're just beholden to whatever the platforms want to put in the world on their own terms. And I also think ethics, it's easy to talk about ethics, but frankly there are billions of ethical systems walking around in the world. Each one of us has our own. And I think the notion that, for example, relying on the government, with a law to say this is the right ethical standard we're going to apply to the companies and what have you, I think it's wrong, or I think at least it's misguided, or I think at least it's not complete. That in fact we should be ceding a lot of the territory to the average person to be the one to have their ethical systems through digital twins and lots of other cool technologies put in the world so their full autonomy and agency is out there for the platforms to reckon with, rather than us having to reckon with whatever minimal standard they apply to us.
Ruth.
Say it again. It was ethical considerations are a hindrance?
There are those who would argue that, thinking about the ethics is a hindrance to the technological progress in the industry. For example, let's roll it out through education without thinking about the impact of that on the students or the teachers or
So your question was, what would I say to them?
Yes, what would be your thoughts?
My response would be, what is wrong with you? Because the only concern with that, though, is that, as they've just discussed, that the ethics are an individual concern. And so if you're imposing your own ethical standards on a classroom or a curriculum, and then banning things that don't conform to your ethical standards, then we're getting into some dangerous territory.
Well said. I think we saw a lot of that with some of the early system instructions and some of the models. Last question here, and then we'll wrap up and get you all over to the Hotel Dina for Twilight. How can we best balance this technological advancement with the societal impact that it is definitely going to cause? Why don't we start with you, Steve? You're looking at me like you're ready to answer this.
It's, once again, very complex, so we better get on it. That's all I can say. Get to work. That's, enough talking.
In my previous incarnation, I was a public policy lawyer, so the first thing I would say is don't look to the governments, particularly in the current one in the United States. Unfortunately, they have a very particular perspective on things like AI. It's all about America first, America always, which I think is a pernicious approach if we're trying to think about a much broader, deeper impact on society and how we should be preparing for it and preparing the people who will be the actual recipients of, hopefully utilizers of the technology. So I think it is sort of up to us. It's up to the industry writ large, our community, our ecosystem, whatever terms you want to use, to try to come up with some of these standards and ways, again, of bringing the average person into what we do so they feel comfortable with the technology and excited about it and want to use it.
Well said. Zach, how about you?
So, real personal subject. It comes down to education. And it comes down to the hero. Each and every one of us are a hero. Each and every one of us is data, is personality, is relationship, is multi-dimensions. And I cannot stress that enough. We are not AI. AI is a tool. But AI has the capability to unlock potentials we don't even know we have inside of us. I think understanding that element and focusing, and I use Pandora's box as a metaphor in a lot of my conversations, all the ills of the world are released, but hope is more powerful than all those ills combined. We need to hope, and we need to educate people on how to grasp that hope and how to work with this technology in the future. And we need to build the systems that we're talking about at Quai that will give us a platform for this.
Well said. It's all about education, Ruth.
Yep, you stole my line. I don't teach in social sciences. I don't teach hard sciences. I don't teach physics or mathematics. I teach in the humanities. And I think if we keep this innovation in the humanities, or at least with a focus on the humanities of humanity, singular, then I think we're going to be okay.
Well said, well said. Well, thank you, panelists. Really appreciate all of your insights today. Thank you, Zach, for stepping in here. Riza, why don't you take us home? And again, Hotel Dina, straight out those doors, down to the end of that breezeway there. You'll see the Hotel Dina off there on your left-hand side. Come on in. You're all invited. Thank you so much. There's some food over there.
There's going to be food.
There's some drinks
and
over
drink.
there. And there's some great community and conversation, which you all heard today is, just so essential to, doing this work. So
I just want to get the Quai site up here, so everyone can see. Just go through the agenda so we can talk to that. Look, my teacher wife says in a lesson plan, you tell them what you're going to tell them, then you tell them, and then you tell them what you told them. So I'm in step 3. Let me tell you what we told you today. We told you about what is Quai. We are the Rebel Alliance fighting against the monopolization of this technology we call AI, which could be truly uplifting. So if you want to be a Jedi Knight and come and join us, you can earn one of these. These we're not giving away free. We're going to give them away to the speakers. We're going to give them away to the Quai volunteers only. And the hackathon finalists we're going to give them away to. So look, this is your Second Amendment shirt. It supports the right to bear arms. Okay. And that is the best effing interpretation of the Second Amendment. Okay, so look, you are the fighters. There's a window of opportunity, as I think Faye said. There's a window of opportunity to steer AI in a less dystopian path, and you can't rely on, now more than ever, you can't rely on government to protect you from the excesses of corporations and vendors that just want to use your personal data for their benefit. There's no cavalry coming. You are the cavalry. So if you haven't joined up to Quai, ask yourself why not. You should just join up. It's a low barrier to entry. Go to the Quai.ai website. Let's build the Linux of AI. We're going to see you at the, we're going to see you, there we go, and he's going to scroll down, and we're going to go to the Quai Light reception. It's at the Hotel Dina, so 2-minute walk down the alley, and there's snacks and there's drinks there, and then you can have the one-on-one Q&A with each of the speakers. So look forward to seeing you there. Hey, we've got a booth starting tomorrow. The expo starts 2 o'clock. We'll be doing booth setup, and we'll be doing our weekly Friday public meeting from the expo floor. We do that every 10 o'clock every Friday. So put that on your calendar. Come and join that as an observer, or one day you might want to become a speaker there. We are going to have the booth from the 7th through the 9th. And then on the 7th, let's scroll down there, the 7th, in the evening is the Personal AI Investor Reception. This is where investors can get to meet with the innovators. Well, first of all, who are the innovators? The innovators are the finalists of a hackathon that concluded yesterday. We're doing the finale tomorrow, and we'll be doing the judging and the award ceremony, Shark Tank-like, and it'll be in the same venue, the Hotel Dina, and we've invited a few investors to take tables there and be part of that final, the hackathon finale. So investors, and then here's the booth. The booth is going to run from the 6th through the 9th, and we're going to be doing book signings of 3 authors. So Richard Witt's book, Reweaving the Web, and Faisal, where are you? There's Faisal. Faisal, you should get to meet Faisal. So Faisal is the founder of TechCon SoCal. And last month we were kindly invited there to speak at TechCon SoCal. Faisal's got a book, and it's on sale at the booth as well. And then Larry Namer is a Quai board member, and he's the founder of E-Entertainment. So his book, I don't know if it's going to be on sale there, but you can definitely speak to the author. He's going to be there. We don't know. Look, we don't know when people are going to turn up. But look, the booth is going to be there 2 till 6. And so swing by there. Okay, thank you very much. Over to you.
Well, thank you all. Really appreciate it. Give yourselves a round of applause as well. That's it. Let's go have some drinks. I don't know what that.
Sort of budding operations. So we have once a week.
Oh, battery pack?
Meeting of the Europe chapter, and it's just I know there are a lot of Italians who are involved.
Yeah, my stepson is
Growing hair is always good. One night of sleep, good. Coming back.
Africans and Italians, I'd say,
a week too much. I don't remember seeing. I don't usually go because I have conflict to that meeting. Yeah, I'm gonna go over. I'm a little unshowered, so it's an ongoing.
The website is up.
Yeah, I had to take the corner by yourself. Yeah,
point him at.
I do believe once if he is able to join, I don't know if it mentions that chapter,
get my laptop,
so have him join, and then he'll find it on the Slack.
Okay. Thanks a lot.
Sure. I don't know if I've ever told you. They told us her dual for the stage 4 brain metastasis heart condition. They told us she wouldn't walk. 2 pieces of machinery, multiple shunts, multiple taps. I just think,
left me, I designed it with a baby touch. And I basically took her through emotions, right? From the time she came home, I took her through all these emotions. And I grew up in New York, I'm freestyle. I grew up in the era of hip hop, so I've been freestyling since I was 16 years old. So I would freestyle to her hours every day. And sometimes I would read to her, but I would sing a song with words. So, I guess it helped. And so we took her today to the neurologists, and they said, we don't want to see her for a year. See, I had to do that.
Yeah, then you're going to.
Yeah. Team PMI, but it's all right.